The kill switch is just a little caveat. I mean, when we get to the end, I have a few slides on how I personally build payloads, but the kill switch is one of my favorite things. Just by having the extra step to host it remotely, just turn it off when you got your binary. I love that kind of level of kill switch. So the second thing, sometimes it works, sometimes it doesn't. But you fix your NGP, it's all good. So you go back to Discord. You get called a noob. Is what it is, Discord. And you get told this, and you'll see back from, I don't know if our red team is still going or not. I've not heard them for ages. But this is one of the things I publish a lot of, WinAPI functions, and you see it all over GitHub. So a little bit of background for the imports people who aren't aware what they are. This is CFF Explorer. Does it say the file name in here somewhere? It does. On the tab, you can see this is Notepad? Why is Notepad importing Paint? Either way, this is Notepad. Just looking at the import directory, open to user 32, and you'll see some imports. That's kind of what this executable we're using. Right, so there is a thing called MalAPI. Is that the reference at the bottom left? Yeah. So MalAPI does this really cool thing of grouping Win APIs to certain. Oh, did I go backwards or forwards? Like this. So MalAPI, you'll see a bunch of these things. You get injection, ton of files. Enumeration, ton of files. Invasion, ton of files. So typically, in most proof of concepts, you'll see that chain of Win API calls. So you get virtual alloc, memcopy, virtual protect, create thread, wait for single object. So if you've ever written implant before, you will have probably started with these guys. And conveniently, if you ask ChatGPT for an injector, it gives you this, which proves my point exactly. Yeah, just double check. So the fact that ChatGPT spat this out kind of proves that this is like the go-to. It's like the most known way of doing this. And maybe this is the solution you went for the first time you did this. However, you can take it a step further if you want to, and you can do something like this. You can resolve them dynamically. In this case, it's just get proc address with some strings, whatever. Maybe you're really cool and you do it with a PEB. So you've got that, which, it's cool. It's probably how the Git FUD level of things are doing it. So you've gone from, Meterpreter just shoving the imports in. So now your binary's just got a list of functions that are going to do injection. Now you've resolved them, you removed them out. A potential data science solution here is to find binaries that have the get proc address but really low imports. So if it has get proc address but no imports, then it's probably going to resolve them. And then if it's got no imports at all, again, super weird. To take that a little bit step further, this is from our friend Rad. He put this out on his, I think it's called his MISC repo. But this is an example of using, was it RTL? What's the function called here? I don't know. It's really small. RTL register wait. So this basically just puts, say, thread callback on load library, then when it loads library this way, you get a clean call stack. So this is like the caveat, not the caveat, this is the difference that occurs at this level where the imports are being imported specifically. So the ones from back here, these guys, if we're using this load as an example, these would be dynamically resolved. And then you might want to use some other bits, which slide is it? This one. And then you'll also maybe you could import a bunch of extra things to kind of throw off telemetry, so maybe a bunch of registry type of things. So you get a mixture of imported things, and your malicious ones resolved dynamically. So if you're also doing staged, then obviously WinINet, WinHTTP are things that will be resolved. And then the extra step that occurs at this level is the care that goes into things like the call stack. Because if you're looking at Elastic, really great call stack inspection, this would be that level, although I do think they detect this individually. If you take all the samples and you unique the imports, you get something like this. And the distinct difference here is goodware is all standard lib. Malware is balls to the ball. It's just straight up, we're going to do stuff with the Win API. There's no difference. So onto our considerations. I think it's pretty much what I just said. You want to resolve some functions and not others. So, as I said, you want to hide the ones that are going to do your loading process. So that'll be your injection functions, your staging functions, and then maybe not some others. So if you've got, try not to implement your own standard lib, which I see a lot of implants doing. Maybe use those, then you get more to the level of goodware. Implement some junk, kind of things. Query some registry keys that don't do anything, then maybe sleep after that for a while. Just kind of make the temperature look really weird at runtime, especially with MGE when they're tracking you with ETW like that. And finally, what you can also do is you can do something like this. You got to be very careful with this, because if you overwrite functions that you need, you're gonna break it. But you can use like things like the Leaf project, or if you're really fancy, you can do this at the linker level, and you can add fake imports. So what this function does is from my payload framework, not the TS one, trusted set one. But what you're doing here is you're dumping all the imports from a function like MS Paint, and then creating a dictionary from those, and then pass it into this function, and this will go through them, check if they're not already loaded into your binary, and shove them in. So that way you get your code, you've got all your imports, you've got dynamic resolves, all these other things, but now you get an extra layer of faked, spoofed words kind of protection as well. Yeah, and it gives you just an extra level of obscurity to it.
Right. So you fixed the entropy, you've addressed the file size, you looked at your imports, your exports, code signing. You brought in your implant, it's finally compiled, and this is like the coup de grace. This is just the nice additions. Stuff. Huh? Yeah, the cherry on the top. So what do we see in the data? Most malware does not care for code signing. We have just reviewed on the next couple of slides how malware that is using code sign has implemented it, but just standout things here, pretty common, almost surprising in Windows that a lot of it wasn't, about 50-50. Not too sure exactly why that is. It's hopefully something we'll be able to elucidate on in the white paper. But for goodware, really common now. We're thinking it's probably because of the large amount of Windows internal stuff we've used, which maybe isn't signed or could just be old. But when it comes to how malware is signed, that's the interesting thing. So the next slide, looking at the certificate authorities that have been used across Windows, malware, and goodware, there's a couple of things that stand out to us. First one being Windows, unsurprisingly, mostly signed by Microsoft. So just because these percentages don't add up, some certificates are present multiple times in each sample. It's not a failure of maths on our end. It might be a failure of maths on our end, but we don't think it is. Overwhelmingly, Microsoft is being used to sign Windows. Goodware massively drops down, only getting about 11% of samples being signed by Microsoft directly, or there's a handful of other CAs in use. However, DigiCert comes up, a lot more common in the Goodware. You can see on the bottom right circles here, in the incredibly small font that you probably can't make out from over there, but about a third of samples are being signed directly with DigiCert cert, but if you add it all up, pretty prevalent across the whole data set. And then we get to malware, which we started cataloging the ones which were known to be stolen, but then we gave up because we got confused about which ones were. There was a lot of Googling, and this was last night, so we ran out of time to do it. But our gut feelings, basically, these ones were the ones which have been stolen and known breaches. They're known to have expired. You can see, comparing it to goodware, they're basically not in use anymore. And then there's a little circle in the middle. So when you're looking at our cast, we're looking at the better here, because it's kind of hard to, Interpreter, you're not going to bother signing it. You get fudge, you might just grab a stolen cert and chuck it in. But when it comes to our better one, we've got Microsoft comes back again. So it's quite hard to get a Microsoft cert. It's a bit of a hassle. But if you can do it, you need to just set up a fake company or have a company that's willing to front you. Buy the cert. There might be other ways. If you know if there are any other methods to get a hold of an official one, please let us know. But you also see some other paid-for vendors here coming in very low on the malware side, but a bit more common on the goodware side, like DigiCert, and like the other vendors here. But Microsoft is the interesting one, I think, for us. So if you can get a hold of it, there was something we were interested in, maybe as an exercise for the audience, which was, can you use ADCS certs as code signing within an environment? Not something we're aware of, but it sounds interesting. If any of you want to pursue that and then just give us a repo that works, that'd be cool. But basically the takeaway here, don't use stolen certs. It's really obvious. It's obvious it's malicious, because at this point everyone's known and revoked that you can, but there's a difference between, do I need a shell now? Is this the thing that's blocking me because it's not been signed? And do I want to actually have a persistent? There is a low bass, I think. Lobats for certs, maybe? We can't remember. Again, we're good at our jobs.
Just go back a sec. I want to expand on the ADCS thing. So if you output a code sign set from ADCS, when I worked at an EDR company, this was something we looked into quite a lot, and it had some interesting results. But I've not seen any work happen with it. I've not ever tried it on a red team or anything. But we're very interested to know if you pull a code sign set, does EDR handle that differently? But caveat. So this one's compiler. In our experience, can't be unstated anymore. So we've compiled in MinGW, and it's been caught. But then we recompile the exact same code in Visual Studio, and it works. And then I never really touched CLang, but when I have, it's never really been consistent. So trying to figure out why that is, right? So there's this great project called Detect It Easy. Hope that's what that is. It is. And this is really good. We found this Thursday evening, I think. No, we knew about this is the next few slides we found out later on. But we've realized we could do this Thursday evening. So Detect It Easy is amazing. Oh, yeah, right. So we tried to do this manually. You can grab the rich headers with the Leaf project, and you can Hasherazade, if that's how you pronounce the name, has a library, and then internal library, there's a switch statement that tries to calculate the compiler based on some other bits of information. We tried to do that, but it was extremely inconsistent, so we ended up finding this. And if you open up the signatures and Detect It Easy, you get this, where you're just basically just doing a bunch of a Pythonic switch on the linker version, and they're trying to turn it that way. There's also some other stuff, like calculating some of the rich header stuff and some of the bits and pieces, but we're going to go with this. So far left, Notepad, the compiler count to be MSVC. Top right, random malware sample is, where is it, pure basic, or whatever that is. And Spotify, again, was MSVC. So this is the view you get. It's really cool. Come on, Captain. So, rich headers. These are weird. We mentioned them earlier, and we tried to do it. Well, we pulled the data, we just couldn't find the right way to do the switch on them to figure out specifically what the compiler was. So in 2020, ESET released a paper, which they called Rich Headers, Leveraging the Mysterious Artifacts of the PE Format. And they say in there that this has been in Visual Studio since VS97, but they don't give any reference as to where that came from. It's a mostly undocumented feature, as of last time I Googled this. There's a bunch of research coming out of people trying to figure it out, but ultimately it looks like this. It's this thing. Next one. So what it comes down to is this. With the rich headers, they use an XOR value to try to tie it back to the compiler, the linker version, and that's the program ID and some other bits and pieces. But they use this XOR value to do that. And on the left here is like an excerpt from that paper. It's basically them just complaining about how it's undocumented and something about VS1993. Feel free to read it, but that's what we're going for. So we queried our data that we had, and we just checked the Boolean, has rich headers. And that's what this is. So across the board, everything is in what was that, 65? Around 65% of things have rich headers. So we wanted to look into more that was. So we didn't trust our own parsing of it, just because the Pythonic switch was a bit odd. So we found this next thing. Elastic have this. It is a Python wrapper API thing for Detect It Easy, which is what we discovered yesterday. We ran it all day-ish yesterday, and managed to get through just under 170,000 samples of it. It took a hot while. But unfortunately, we were only able to get through the malware ones. So what's interesting here is 57% of the malware that came back was MSVC, and you can see some wild things in here, like JavaScript's down here. We've got Go, we've got Free Pascal, Masochists, Delphi, and Visual Basic. Whoever's writing malware in Visual Basic. And what we're trying to do here is tie this back to the previous slide of the 60-odd 5%. Which was this guy. And the numbers kind of match up. So on here, 57, you got to appreciate that we didn't finish the whole data set, so that number has some variance to it. But it's about the same. Where are we? We're here. So what we're trying to do here is map it back. So in Interpreter, that should be the code for the compiler code? Yeah. So you can see MSF Venom compiles with MinGW. Cobalt Strikes implant is also the implant, not the loader, is also in MinGW. Gitfud, depending on the author, really comes down to MSVC and MinGW. But for the most part, my recommendation, as not an authority, is to do everything in MSVC. That is typically where everything is landing for goodware, malware, and obviously Windows, 'cause it's theirs. Do you know what I mean? Yeah, with the caveat of caveat of what? Sorry. Okay, we've not done it yet, right? So we may manage to get through this for malware, but I'd imagine that you'll see for Microsoft it'll probably be a lot higher than 57% because they're not going to be doing things in it. Although you might get Rust in it now. They're moving to Rust, right? So you might get some of that stuff. But we have a lot of old. Yeah, our data is kind of a bit older than that. Sorry, what? We still have to reprocess. You've lost me, mate. You completely lost me there. Oh shit! Oh, one sec. Yeah. So go back. Let me conclude the compilers. So yeah, we'd imagine if you did this across Windows and goodware, you'd get a very similar thing. And obviously, when we're doing this, we want to impersonate goodware. You can go for Windows, but we'll talk about it in a bit. It gets really complicated. So one of our honorable mentions is sections. This got complicated real quick because there is a lot. These are the documented ones from MSDN. So if you load up the MSDN PE format, you'll see these guys. There's actually not other column with loads of offsets, but these are what we're considering standard. So when we look at these, does this graph have? So we get something like this. This is the top 25 section names in goodware. Let me come over here. So you'll see the usual suspects like resource, text, relocation, our data, the various datas and the TLS and those kind of things. Oh yeah, and then if you look at Windows, they're only really using text, resource, relocation, data, and our data. But this is one of those things where you kind of just fire an ML. Really, there's nothing typically realistically actionable here. I don't think. But what was you just switch slides? What have you switched to? Oh, then you look at that across malware, and it gets funky, man. You got these guys, who nothing came back with those guys. They didn't pass because they were random bytes. You got UPX. If you're familiar with UPX, don't use that. That's awful. And things like new secs and new sections being made. ASPack, that's another packer. These things really stand out. So when you start to look at using packers to protect your binaries, you are creating new sections typically. I can't speak for all, obviously, packers, but the main ones like UPX, ASPack, they're going to create these things. And they're just anomalies straight up. So I guess the only actionable thing here is to just not pack, really. Just take better care of your binary, have it outside the binary cache strip, take care of it. In the paper that we have, we've expanded on these a little bit. So the resource and .text, we expect it to be massive for malware. Just typically that's where people shove their shellcode and things like that. However, it doesn't reflect here, which is interesting. But I suspect when you look at the entropy of these things, again, that's in the paper, not much in this talk, the entropy will be much higher for those in comparison. So the best practices, with all that in mind, there's a lot to consider. Building implants is hard. I think the people that put it online that it's mod devs fun and easy are, not considering all the possibilities. So, next slide, please. We have this monstrosity. So I have a blog coming out for TS in about 2-3 weeks that discusses the first 4 cells of this. But essentially, we have this key up here, optional, preferred, and paranoia. I'm extremely paranoid when it comes to payload generation. The blog that TS are releasing is about how Alice PC checked into my C2 not long ago, and I hated it. I nuked the whole C2 and did everything again. But we're going to talk through this. So we're going to break this down into a few different categories, as we'll see going through the slides. But we have these things. So environmental keying, host keying, and external keying. That's a lot. They really should be read, but I've made them optional because I think you should always consider them. So environmental keying, I don't know, check the environment is correct. So the domain name, a file exists in sysvol, these kind of things. Host keying, obviously specific to the host. You could use like the cryptography GUID. Caveat with that example is, I think if you use a golden image, the system GUID's the same. You could use host name, username, whatever. And then I had a third one for external keying, which is trying to pull out an IPv4 from like a DNS record or a GUID from a TXT record, that kind of thing. Just to make sure I can get out of the environment. Again, that's incredibly paranoid. You probably do one of those things, but I do all three. Anti-debug and anti-VM, maybe if you're feeling fancy. I've never actually used those. That's not true actually. I've never used anti-debug. Anti-VM I've used once or twice, but that's usually as like the persistence one. So once it's landed and I'm happy where I am, then I can just lock it down to that that virtual machine technology, just in case guy takes it off the VirtualBox now. Then you can't fire it. We've got the retrieve payload remotely. That's a paranoia thing. You can shove it in, and you can use Mark spoke about with UIDs, MAC addresses, SVGs, CSS, transforming the shellcode into something not normal. Then we get the loading routine and execution routine. Obviously, if you don't have those, you're not going to fire, right? So loading routine can be whatever you want it to be. The typical approach is virtual alloc, protect, mem copy, those kind of things. You can get as fancy as you want there. Then obviously the execution routine, how you're going to fire that off. And once you've done all those things, you end up in these final steps. Defensive impairment, don't always recommend doing. That's definitely a case-by-case with the EDI you're working with. If you want to work with ETW, AMSI, WFP, go for it. DLL load, callbacks, those kind of things, nuke all those if you want to. Then you get some post-execution cleanup, doing to free memory, delete a file, or stuff like that. And once you're at that point, you're in the PE management, which is kind of, does this technique I'm doing require specific exports? Am I a COM DLL? Do I need to do DLL get class objects and all these kind of things? Entry point, am I changing the entry point for whatever reason? Probably not. If you're using something like, I guess, RAD again, is WTSRM project that has a custom entry point, but his whole thing is bringing the CRT out of it. And binding post-processing, so that's like code signing, the embedding, the spoofed, I don't want to call them spoofed imports, but not to call them, adding another PE's imports into it. And these fall into these categories where preload, load, post-load, and post-compilation. This is how I plan to build an implant prior to any stage actually of a red team. And again, it's just instill paranoia the way I do this. And if we map this back to what we spoke about today, we get something like this. So your entropy is directly impacted by the file size by pulling it out from somewhere else. You could probably even replace that with like WebDAV or an internal UNC share. We actually did that yesterday. Internal share did that yesterday. Imports can be managed down here, as well as the imports. So when we say PE management as well, that is resolving some things dynamically, importing others. Again, to kind of mask the intention of what your binary is going to be doing. And then you can use it in binary post-processing of shoving them in after the fact. And again, signing is obviously a post-compilation. Well, with MSVC, it's during compilation, I guess, right? But those kind of things. So that's kind of my process of doing this. And it's one I would encourage other developers to kind of, I'm not saying use my methodology, right, but at least think about it at this scale so that when you come to coming up against different levels of EDR, you can plan accordingly. And that's what this kind of goes for.
So cover the methodology, had a look at the data across goodware, Windows, and malware, and thinking with this sort of how we're going to approach building a payload for a given project with that in mind. Final thoughts. Again, appreciate this is a really quick run through of a subset of the total sort of stuff we've been able to do, but based on the wider sort of data we've gotten back, some initial ML, AI stuff we've been doing as well, and this, some pretty straightforward conclusions really. Windows is really hard to mimic. It's hard to mimic exactly accurately. It can be done, but it takes a bit of effort, a lot of effort, takes a bit of investment. You've got to be willing to have stuff burnt. From at least a static perspective, there's a lot of things to get right, and it might fall apart when you start one time. There's probably too many things to get right. Mimicking goodware is a bit easier. There's a lot more variance in the data. There's a lot more room for you to fit in, basically. Most malware doesn't even bother. So from what we can see on the data, most malware that's still working, balls to the wall, just run. It's a bit like the sad feeling got looking at like the Conti leaks, where it turns out they just use PowerShell, like APTs just use PowerShell. And it kind of fed into this sort of pet theory we've been toying with. I don't know, I think I've probably heard other people speaking about it as well. Not going to call it original, but this idea that pen testing as its own IOC, as its own like APT label, is kind of distinguishable from actual malware that's in the wild, and it kind of stands out. You can see, even going back to the code signing, there's this kind of, some people have bothered to sign up for a company just to apply for a Microsoft certificate, coming all the way back into mimicking the imports, getting the research right to kind of blend in. But the main takeaway is really, that is a great thing to do. If you can do it on every project, more power to you. If you can afford to do it on every project, even better. If you have clients that you can afford to bill for it, cushy, that's the right place to be. But for the most part, if you're just shoving shit out based on you've got a problem and there's an interesting binary you found that can solve it, or an interesting project, sorry, that can solve it, fix your binary, it's probably not going to be great. Just shoving random stuff into your implant, doing a little, but then not bothering to do any post steps afterwards, is going to make you stand out more than if you just use Meterpreter, at least on a static level. There's the caveat, obviously, we've done this statically. At runtime, you're going to be probably nixed immediately, but it's just this interesting horseshoe theory coming in. But yeah, worse than using a well-honed loader or even Meterpreter, but with that same runtime caveat.
One other thing to mention with the final thought on this slide is, I can't remember his name, OA Labs guy, I can't remember his name, but he's always talking about on his streams how he can spot a red team implant immediately. And that's kind of where this whole idea of talk came from, was how could we stop him from thinking that? And it comes down to very carefully mimicking goodware, and not in the fact of taking one, cloning its attributes, shoving it into your binary, looking at how what the unique aspects of these goodware are, and then trying to get them into yours. That's kind of the general gist. If you're going to use some sort of Git FUD, something straight on Git or Twitter, you're going to fire it off, it's probably not going to go too well for you. It's the bottom line. Put more care. Think about everything that the implant's going to be doing. Which brings on to questions. Anyone have any questions?
1.5 minutes of questions.
Yeah.
It was not tactically done, but
have you put any work into detections based on the research?
No. The question was, have you put any effort into detections? No. So at the beginning we mentioned that this isn't necessarily great for blue team, this talk. It's vendor specific what we're talking about here. Because I guess you can't put in you could probably do some Yaras and look at things like that, but it's going to hit a lot of false positives.
there is something interesting which we are exploring, which is not to jump on the hype train, but training models on this just to be able to say, this is a sample, tell me what it is. You ran some tests so far, like, what was it, last week? Getting some...
Based on imports.
Yeah, based on just inputs alone, was it 97, 98% accurate? So it's pretty good. It's not enough to immediately ban it, but yeah, just based on this data set alone, we can actually do some stuff already. And again, this is publicly available. You can pull it as well if you want to have a copy of it.
Yeah,
but
it's more vendor specific than blue team specific, this. Yeah, it's more aimed at vendor than blue team, at this level anyway.
For the code signing section, did you notice that the malware certs were legitimate, like stolen certs, or were there also like fake certs, like sign like the SIG-D or the limelight or something like that?
The question is about whether the code sign certs were stolen, bought for, or used with like SIG thief and these kind of things. So the...
we don't distinguish it.
No, we didn't distinguish it, but if you look at the certs there, Komodo typically have a very easy process to get them. So we're presuming, we don't know is the bottom line. Symantec though was definitely, was it Symantec that was leaked? The Symantec one was leaked. The Komodo one, I don't think ever got leaked, but a lot of malware is signed with it. But I do know they have a very lax process to verifying that.
It's probably an interesting thing. I don't think any pen test company would agree to it, but it would be nice to compare actual operational pen test and red team against the general malware corpus, because what we're seeing in malware is going to be skewed by the fact that this is going to be random rats. It's not necessarily just going to be that pen tester sample set, but I don't know any pen test company that would agree to do that. I think we're at time now, but yeah, just to say thanks to colleagues Dan Mead and Chris Bendowski for the help reviewing the data set, because we locked them into quite a few calls for hours at a time going over it. And thank you all very much for listening.
Oh, there you go. Boom, boom, boom. Justine? Yay. Time we on? Are we good for time? Are we good for time? Okay, cool. Morning, everybody. How are we all doing? Thanks for joining us on this hot day. Sweaty. I'm so glad that this year they've gone for, like, you know, wristbands and sweatbands because, yeah, we all need it. Thanks for coming to the talk. Just as a little preamble to this, I've written this and been through it a couple of times with people, so I'm hoping you guys get the value from it. Quick hands up, who of you are students looking to break into the industry? Who of you are from companies looking to probably take on juniors and what have you? you can go. It's fine. This is not for you. Awesome. Okay, so just a quick about me. For those who know me, you already know who I am, but for those who don't, my name's Alex Martin. I am the Director of Cyber at Cyber Hogan. 20 plus years in the industry, providing primarily offensive security services, pen testing, red teaming, social engineering, all the good stuff, all the cool and funky stuff. I also run a consulting, a mentoring consulting service to students trying to get into the industry, to build up your confidence, get you prepared for the industry, and help you get a job at the end of the day. So if anybody's looking for a mentor, please reach out. That's also available for any professionals that you know who are looking to move within the industry as well and looking for a new challenge. So, I do help senior professionals as well getting into that new position. And then I am also the lead lecturer at Correlation One. This is an organization that's working with Amazon, getting warehouse staff upskilled into cyber. I think the premise behind it is basically it's easier to recruit from internally than go out to a recruitment agency and pay the fees. So I'm helping train up and bring into the industry some new talent basically through that. Okay. This whole talk is about what employers are looking for and how literally in a bolt of lightning I've come up with a theory which, if employed, should solve the skills gap in essence, right? Which we all talk about. But what are employers looking for at the moment? And this is the start of the problem that we've got, right? This is the problem. This is what I've been thinking about, trying to find a solution for the last couple of years primarily. But what are employers looking for? Every advert you'll see out there for a role in cyber at the moment needs a degree and needs 3 years worth of experience. Okay? Set 3 years number just to pay attention to. Unlike an accounting degree, sorry, let me just go back one. Unlike an accounting degree, when you have finished an accountancy course and you've got your diploma, or you've got your degree, or whatever the case might be, you can go and do that job the very next day, jobs are good. But in cyber, you do the course to learn the subject matter, and then you go and work to learn how to actually do the job. So that's really difficult, because how do you get to learn the job if you can't get or how do you get the job if you haven't got the experience, because you need the experience to get the job? That's that circular problem that we've got. But what does a degree show an employee, for starters? Let's start there. Because the 3 years experience shows that you know what you're doing. But what does the degree show? Particularly in cyber, again, when I come back to sort of marrying this up with an accounting degree, for example, where you can go and do that day one after graduating, what does a cyber degree show an employee, an employer? Well, what it actually shows an employer is, one, you're interested in the subject matter, because you stuck to it for 3 years. For a bachelor's, an additional year for a master's if you have. So you've got staying power. Not only that, but you can also meet key milestones for delivering information, and you can produce a report at the end in the form of a dissertation. And when it comes to pen testing or any consultative work that you probably will do afterwards, there's always a report at the end. There's always a dissertation, right? So it shows, again, you have that staying power, you have that interest in the industry, and you wanting to do it, you want to get involved. So an employer is not looking for somebody who's going to, jump ship and jump jobs and jump roles every 2-3 months or whatever like that. If you stuck to this for 3 years, it's more than likely that you're probably going to stay at that company for 3 years, gain that experience, and therefore become a senior and move on. But you've got to get the job to start with, to get that experience, which comes back to that whole thing at the beginning of they're looking for a degree and the experience. Experience is the problem. There are other certifications, other paths, other ways of highlighting that you have the skills and experience. There was talks in the industry amongst professionals who, amongst the pen testers and whatever you like that, about is it a degree? Because just to say as well, the pen testers, they've got the jobs and whatever like that, but they're not the ones employing you guys. It's the businesses that are employing you guys. It's HR. It's the managers, the directors. It's not the pen testers. So they're on your team. They're on your side. They're trying to make it not easier for entry, but they're trying to think of a different way to get into the industry and portray your experience, right? And give the evidence of experience. So there are other ways. There are other certification paths that need to also be taken once you've sort of joined. And just to give you an example, there is CREST. Everybody's heard of that probably. Certified Registered Ethical Security Testers. There's the Czech certification path. Typically that's government-backed stuff, public sector. And OSCP. Most organizations, when you join with your degree as a junior, will be asking you probably to go for OSCP first, and then CREST after, and if they're dealing with the public sector and government agencies, you'll move on to Czech. But instead of a degree, a lot of the guys I was talking to over the last few years have been like, well, why don't we use Hack the Box, Try Hack Me, and Capture the Flag events as evidence towards your experience? You know, if you've been doing this since you were 16 and you're in that top 1%, which I think they do give that scoring kind of in that way, why would an employer not employ you? Because you've quite clearly got the skill set. You know, you've had a go at all the different boxes that they've got, all the different methodologies, you've played around with it. You're not a senior still because there's still real world scenarios that'll throw a curveball out of left field somewhere. But on the whole, you've got quite a plethora of experience here that can be gained through these additional platforms rather than just going for the degree. And if you've been playing around with this kind of stuff, you've got that actual tangible experience that the degree doesn't give you, because a lot of the degrees are talking about theoretical risk, data analysis. There's not pen testing. It's not, you know, it's the security theory, not the actual hands-on, right? So there are additional things that you guys can do which will give you a representation of the experience that you have and you're bringing to an employer. However, the real way of sort of getting into the employees, and this is theoretical at this point in time, but it makes sense and it's about to get tested. So bear with us on this one. You know, evidence of this will come out in the next couple of months. But the way to get involved is not to be that typical hacker, you know, that we see in all the pictures and stuff like that from all the leaflets, hoodie on, mum's basement, you know, all that kind of stuff. No, right? You have to assimilate. You have to join the group. A phraseology I'm running at the moment, or a phrase I'm saying a lot at the moment is, if you want to be in the game, as in you want to be employed, you want to be in the, have an opportunity. If you want to be in the game, you've got to be on the board. You've got to be seen. You've got to be a player. Right? And the first starting point of that is social media. Nobody wants to do that. I understand. However, and I'm going to use the word personal brand. I know, same thing, right? But you have to do it. If you want to be in the game, you've got to be on the board. People have got to see you. People have got to notice you. 9 out of 10 times, the path to opportunity to interview starts at CV, which goes out to a recruiter, or you push it out to HR, or you push it out to a company, or you upload it to a site, whatever the case is. And I say this is kind of like a 3-course meal. That's the aperitif. That's the not even the starter. It's the little something to get your taste buds going, but it isn't filling. You know what I mean? Your LinkedIn should be the main course. And then when you go for the interview, that's dessert, because nobody sells you better than you, right? As far as your LinkedIn profile goes, it should be as thorough and as full as possible. You need a professional picture. I say a professional picture. I don't mean like go out for a photo shoot and get, you know, headshots and stuff. You know what I mean? Unless you're that way out. But something that looks semi-professional, so people can see who you are. Don't have alcohol in the picture and drinks. I know. Don't be, don't be on the holiday scenes with your, you know, shorts on and no top and all that kind of stuff or whatever, right? Be semi-professional, but friendly looking. Do you know what I mean? Okay. Also make sure that you have your top banner. Just come over here a sec. Make sure you have your top banner also with an image as well. For me, that is, I mean, it's the finger of God and Adam, Sistine Chapel stuff, right? But it's reaching out and touching and communicating with people, okay? Because I do the mentoring thing, all right? There, right? It's not that I want to touch people. It's, no. I can see the faces going, ooh. Oh, I'm sweaty, no. Okay, so make sure you have that top image up there. This subheading byline piece is also very important. You have to include the security elements that you're interested in at that point, because whenever somebody does a search, sees down the side, you kind of have that who else you might be interested in connecting with kind of banner that comes up. That's the piece that comes up to start with that everybody sees. So if it's SOC, if it's pen testing, if it's security, if it's red teaming, phishing, whatever, make sure you have all of that in there. And then your about section. Your about section should be 3 paragraphs. Each paragraph about, and this is, if it's granny sucking eggs here that I'm teaching you guys, I do apologize, but, stick with it, right? But your about section should be 3 paragraphs, 3 or 4 sentences per paragraph. Don't make it just one long sentence that somebody's got to read, because they won't. Who are you, as in what's your background and stuff like that? What's your interest, and what's your ambition? Those are your 3 paragraphs. Okay? Again, that, right? And also then putting the ring around your picture of I'm interested in, I'm looking for work, plays into the LinkedIn job recruiters algorithm, all right? That's your primary. Then for the rest of your LinkedIn, every job you've ever had. I don't care if you were cleaning the toilets at McDonald's, right? Interchangeable skills, because that's like customer service in a way. You know what I mean? I don't know. You did the job that you were told to do, so you're compliant. I don't know. But every job, all your history ever, and it should match your CV. CV in summary, this in maximum detail. I used to have to go to B&M every week to get a new toilet brush. No, not that far. But you know what I'm saying, right? Detailed. And then, make sure I'm not jumping too far ahead. And then, also make sure you're posting regularly. Yeah. All of this looks good, but the algorithm loves content. Okay? And all this is doing is bringing you guys up as cream floating on the top of everyone else that's out there. Okay? The market is saturated right now. Cybersecurity is the hottest topic. Everybody's into it. Everybody's doing it because they understand that everybody needs it, and there's a lot in the marketplace at the moment, right? There's a lot of need for it. So everybody's doing it. University students are pumping out thousands a year into the industry, right? So to differentiate you guys here specifically today, seeing this is changing your whole perspective, and it's raising you above that 1%, right? Hyper-competitiveness is the word I've used previously, because it's that 1% at the top that you need to be within the 1% of that 1%. It's crazy, okay? But all of this work brings you to the top, and then post and add content. If you like a post, share a comment. If you're sharing a comment, you might as well click share on my timeline and make the comment on your timeline, right? Don't comment in their post, comment it as you sharing it. Tag the individual back into it, because when you do, the algorithm goes, cool, well, I'm going to let them know that you've tagged them into their post that you've shared, which they'll like. And at that point, what it also does is it actually shows to their network as well in the algorithm. So you're all of a sudden getting maximum exposure rather than liking their post and commenting in their post. You're getting maximum exposure because your network is now seeing that you posted this, fresh content, and all of their network is as well. So your notoriety, you're rising up. The algorithm's going to push you to more people by doing that. On average, you want to be posting probably, as a minimum, 3 times a week. As a minimum. Oh no, hard work, innit? Not really, right? It takes 30 seconds to put a post up. ChatGPT, right? I'm going to say ChatGPT, all right? Who cares, right? We're just adding content and we're trying to increase your network at this point in time and connect you to people and add the content which is going to float you to the top so that a recruiter goes, oh yeah, you're the kind of person because you're active. Yeah, let's get you in for an interview. That's all we're doing here. So ChatGPT, why not? Read it first, make sure it doesn't make no sense. You know what I mean? Read it first and then push it out. You can also use platforms like Buffer is another one, if you haven't heard of that. It's a confused face, I like this, it's just interaction. Buffer is a platform that you can hook into LinkedIn and you can schedule posts. So you could spend an hour on a Sunday making 5 posts that you can schedule throughout the week and you've got 1 a day for that week. You can post 3 times, and you could do, I don't know, 12 posts, schedule them, 3 a week. It's a month's worth of posts. You know, spend a little bit of time on a Sunday night when you're hungover to hell, you ain't got a lot of time for yourself, but just buffer it. Have them preloaded, and then just let it go. But do that once a month, and what the algorithm will do is it will like it will share it, and it will bring your profile up to the top. But that's all been a preamble. Now we're going to go for the red pill. Okay, and I say this because literally I'm sitting there like for the last 2-3 years going, right, we've got this gap, we've got the skills gap problem. We've got the skills gap problem. How do we solve it? Well, we need more people in the industry so that skills gap for seniors that we don't have, which are being charged a fortune because they're like rocking horse poop, we need more juniors in to fill that gap in years to come. We've been talking about this for 5 years now, minimum, right? If we'd have started this program 5 years ago, we wouldn't have the problem now, right? But employers aren't going to change their mind. Recruiters aren't going to change their mind. So we have to do something differently so that you guys have the opportunity to get those interviews and they can't say no to the interviews. How do we do that? So let's believe, again, there is no spoon. It is you that bends. No, it's not. It is you that bends. But the industry is calling for you to have 3 years experience and a degree. And this is the problem. It's a problem. And I'm just going to say this. Problem in maths means that there's also a solution. The problem is the formula, you know, the sum. But there's always a solution. And that's what we're looking at here. Just to say as well, this is trying to reduce the barrier to entry, but even a no can be looked at as a positive because one will say it's, you know, silver linings on clouds, blah, 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 meant to be, rah, rah, rah. But somebody saying no to you, the question should be why. Is it the skill? Is it the skills that I don't have? Is it the experience? Is it that my profile's not right? Is it the way that I've approached the interview process or whatever the case might be? Okay, so even if somebody says no, take it as a learning opportunity. But this, okay, this is the magic. This is the special sauce here, right? Okay. And we've got a kind of employer in the room, so I've got to be very careful about how I put this because the questions are going to come out of it in a minute. But as university students, you're in for 3 years. Employers are looking for 3 years experience. But you're in a university for 3 years. How are you going to get the 3 years experience at university? Easy. Create your own consultancy. Create your own brand. Keep it simple. Let's not make it complicated. That's an M, and my surname's Martin. It's a fucking genius, right? I'm big like a silverback gorilla. It looks like a fucking gorilla, but it's an M. Ooh, genius. Okay? No, keep it simple, okay? Also with this, just to say, it's a freelance thing. So you don't actually have to register it as a company on Companies House. So there's no cost for doing this. Okay, you can run freelance operations and you can invoice somebody if you do work for them and you can get paid for it as long as you declare it to HMRC. Because I'm not saying we're dodging tax by doing this. Okay. If there are entrepreneurial individuals who do start projects year 1 of university because they're so passionate about a subject matter. Okay, some of the best technology we've got currently has probably been developed by some kid who's 16, 17, going to university for the first time and starts playing around with this kind of stuff, right? So in all reality, you guys could have your own consultancy and start a freelancing thing, okay? You don't have to start at day one at university. Most first-year students are just out getting on the piss, right? This is year 2, but you can backdate it, because by the time that you leave university and have got your degree, that's when people are going to be looking at you. So in year 2, year 3 even, you could put this, a freelancing opportunity, a freelancing organization on your LinkedIn, because nobody's seen it yet, and backdate it, okay? I've got to be careful at this point, because we don't want to be doing anything that's not true, okay? But you can add projects to your freelancing job, right, which highlight the experience that you've got. And if you backdate this to the beginning of university, you've got 3 years of experience and a degree. Now, I'm going to add here that the projects can range from everything. And again, there's no university students that I have spoken to who haven't run a project of some kind, whether it's resetting their grandmother's PC, or setting up a Discord server for somebody, or creating a network somewhere, or working for their uncle's company on placement, whatever, I don't care, right? There are projects that you guys will be doing, okay, over time. Resetting your grandmother's PC, that's customer support. That's IT support. At no point on here, unless you put in here project name, resetting grandma's PC, right? At no point are they actually asking for evidence of who was it for? Who did you do that work for? How much did they pay you? If anybody asks how much they paid you, be like $1 million, because it's none of their business. For starters, it's rude, right? You can add whatever projects you see fit that fit with the experience you require for the job. But don't lie. The moment you lie and you start in that role because you're the best, you've got so much experience, you've set up a SOC before, and you've added all the nodes and the monitoring and alerting agents out to all the devices. You've done all that and you've managed it, and there was a team of 20. Fuck me, you're brilliant. And you did that all during university. Day 1, you're fired. Because they're going to go, yeah, do us a favor, just going to have a look at the SOC. You'll be like, where is it? I don't know. Fuck. Excuse my language. So don't lie, but do add the experience under the projects and your consultancy as a freelancer. Now, there is an argument that when you go to interview, somebody goes, this isn't real experience. Oh, really? I did reset that password. Give us your computer, I'll show you how I did it. Because it is experience. Well, it's not real world experience. Well, it was somebody else's PC that wasn't mine. Okay, but it's not industry experience. How many barriers do you want to put up here, mate? Because I can do the job. Now tell me I can't. So this should be giving you the opportunity to at least get into the interview stage, because you have the 3 years experience that they're asking for. There's no barrier. You fill the criteria. The argument of whether it's industry experience stands, okay? And at that point, you've got to kind of go, no, it's not. I haven't worked in a SOC. I haven't worked as a pen tester, rah, rah, rah. But I've done these kind of things, so that's why I'm coming in as a junior and not as a senior. Makes sense? So again, I come back to, if you want to be in the game, you have to be on the board. You have to stand out. You have to be seen. You have to be different to a degree. Okay, same but different. Add content. Look at what's happening in the industry. Let's just take this weekend, or this week, for example. Woke up yesterday, Microsoft outage. Yeah, Azure's down. Half the planet's suffering, struggling. My sister lives in New Zealand. She can't get on her banking. I haven't asked if they got it sorted yet, but yesterday, wiped out, no banking in New Zealand at all. Causes major problems. And then we also see CrowdStrike is blue screening all the PCs across the planet as well. Is it a massive leap to say that Microsoft Azure is using CrowdStrike? Maybe. Interesting content though, right? Interesting thought. Think about this kind of stuff that's happening in the industry and add that content yourself. Start thinking, living, breathing the industry that you want to get into, and add that content on LinkedIn. Be insightful. Be controversial. Ask a question and have the industry go, oh yeah, this is what that is. Use ChatGPT, but read it first. Press the button. I pressed it with my little finger. Oh, there we go, screen. Green testing. Hey, I'm back. Look at that. Technical support. Live and breathe it. Be controversial. Ask the questions. Don't be scared about making a mistake. Okay? You guys are new. You guys are juniors in this industry and stuff like that. Don't be worried about saying something that's a question, but not necessarily, or a question or a statement, but it's not 100% true. Okay? Still coming through, right? Yeah. The industry, 98% of us are nice people, right? We are nice people. We are genuine, right? We'll hack the shit out of everybody else, but we're nice to each other, right? And you may get corrected, but it'll be in a nice, friendly way. That's not exactly how that works. This is it, and here's a few links for your education kind of thing. Do you know what I mean? It won't be that you're going to be blasted from a high altitude and obliterated. Not to be seen in the industry ever again. It's not like that. 9 out of 10 times as well, you guys are not high enough, different phraseology, but not high enough up the food chain to have that message spread too far for it to cause major detriment to your career in the future. Plus, LinkedIn's algorithm makes it disappear very quickly because there's all the rest of the content going in there. So don't worry about saying something that's stupid. There's no such thing as a stupid question as well. Ask the question, otherwise you are stupid. Ask the question. So likes, shares, posts, comments, and articles. Sometimes a post, when you start writing it, can start getting very long, and you think to yourself, this is not a post because nobody's going to read it. This is an article. Okay? So take it from there and stick it as an article instead, and then repost it as a post with this little short little comment thing at the top. Little, like, you know, come and read this. It's only like a minute long, whatever. But it's insightful. And then, so that's the social media side. And again, standing out, looking different from everybody else and whatever you like that. Do events. Network at events. Okay? So you've been seen online, you've added the content, the algorithm's pushing your details up, the recruiters out there are seeing you, but the people who are in the industry that can help you further, who are recruiting and all that kind of stuff, aren't necessarily seeing you because they're not necessarily looking at LinkedIn. They're too busy doing their day jobs 9 to 5. Go to networking events. Eventbrite. Go and have a look. Cyber, local area, right? There are loads. Loads for free as well. Right? The community's huge. We've got all sorts of events going on. B-Sides, Cyber Brewery in Leeds, SteelCon, DEF CON, Black Hat, all of them, right? Network at events. Go to them. Start making friends in the industry. Meet your peers. Meet your future bosses. Because if you go to these events, people start networking with you. You get your phone out and you're like, yeah, connect with me on LinkedIn. And they look at your profile and go, oh, yeah, you're interesting. Cool. Then they see you at the next event and the next, and you become friends. And at some point, that person goes, we've just opened up a position. You're looking for a role, aren't you? And that's how you get a job, okay? Outside of social media. It is who you know, not what you know, a lot of the time as well. So do network. Go to events. Best results can be found through networking with people because that personal touch, that one-to-one basis is extremely important. We lost a lot during the pandemic because of that. We lost a lot. So, time to put your big boy, girl pants on and get out there and start networking with people. And then lastly, is anybody from LinkedIn here? You put your hand up there like you were just, dude. There was a moment, I'm like, this is not for you. This is not for you. Out. That's how you get cancelled immediately. Fucking hell. Excuse the language. Make the machines work for you as well. Buffer. Okay? Buffer.co.uk or .com, one of the two. Buffer. Preload your articles, your posts and stuff like that. Let the machine do it for you so that you don't have to remember to do it. All you have to remember is one day a month I have to spend an hour doing it. Okay? Set a reminder on your phone for that. Additionally, there are other tools, and for anybody who would like to connect to me on LinkedIn who's not already, and if you are already connected to me, message me and I'll send you a link. There are automated tools for LinkedIn. Shh. It does contravene the LinkedIn, we're streaming live and I'm saying this. It does contravene the user agreement license. However, if I'm sending out messages to all my contacts, and it's the same message, because I'm going to an event, and I'm like, do you want to come, 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 do you want to copy and paste, copy and paste, copy and paste, copy and paste. It's the same message I'll be sending out to everybody, so why don't I automate that? Why has LinkedIn not allowed me to automate that already? Seriously, I want to send the same message to all my people, but I want to just change the first name. Because it's marketing, it's networking, it's all that kind of stuff. So there are tools that you can use that plugs into LinkedIn that allows you to do that. I would say as a student, at this point, all you're looking to do is connect to people. You don't even have to engage in a conversation, right? At the end of the 3 years, you will have a network that's of a certain value, virtually, which you could potentially dip back into and go, you know, we connected like 2 years ago. I'm now looking for a job, but the role's going. But those people that are in your network, in your local area, you've probably already networked with at events. So they've already seen you as well. Double bubble. But it's the connecting and the laborious manual thing that you want to get away from, so let's automate it. Let's use AI, machine learning, blah, 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 whatever, right? But let's try and make it easier for ourselves for that mundane task, but grow your network through doing it. So again, connect with me. If you're already connected with me, message me. I'll send you a link. Try and get off that topic because we're streaming live and I'm talking about breaking laws and whatever. You could take that QR code. I forgot to put that on there. Yeah. Just to say as well, there has been a rather huge rise in malicious QR codes over this last year. That's safe, it's fine. We are at a security event, right? But yes, the tool is, does it work? Oh, damn, okay. Oh, okay. In that case, use that one. That connects you to me on LinkedIn, right? Yeah, that'll do as well. But that connects you to me on LinkedIn. Message me on there. Happy to talk outside of this as well. And again, I come back to the mentoring thing that I do as well. So if anybody needs some assistance, a review of the CV, a review of their LinkedIn profile, ideas of how to go to market, whatever you want, please, come and have a chat to me and network with me. Okay, it was 38 minutes, and usually I do it in 15, so I spun that one out all right. Got 20 minutes left at the end of this, and I'm open for questions.
Yeah. The searching on LinkedIn, how do you find the jobs? So I use Access. When I search that, it's really hard to find the roles. I'm open to work, but I can't find them.
Okay, so searching for jobs on LinkedIn, use words around AppSec. Yeah. However, but however, that's what they're putting out there as the adverts. So there isn't any way of going just AppSec. Application security, I don't know, web app, not development, obviously, web app security, web pen testing. Search for those kind of words around in the job section. That's all I can suggest. Yeah. I mean, again, ChatGPT top 10 different words for AppSec. I don't know. It's an idea. I'm not on the board. I'm not getting paid. It's not sponsored by.
At the beginning, when I walked in, we were giving advice to juniors about, just leaving uni. We've left uni a couple of years ago now.
Yeah.
The job adverts that you see these days is they want to be a junior,
Yep.
but have CISP. But you
Yeah.
can't have CISP
No.
until you
No.
have 5 years worth of experience. So
Yeah.
how do you lie your way through that one?
So I tried to take my CISP certification a couple of years ago. No. The exam question that threw me was, out of the correct 4 answers below, which one's the most correct? fuck you. Sorry, language. No, that's ridiculous. That's not the. So
That more and more in job adverts.
you are seeing that more and more because there's either two things. One, it's a fake ad. Seen lots of those around. People posting up ads saying we've got this role going, then you go for the interview or you get promoted into it or whatever like that, and they go, oh yes, we're only going to start interviewing in February next year. It's like, what the fuck? Why is it advertised now then? Or it's an individual that's got a recruitment agency involved, and the recruitment agency has gone, oh yes, for this kind of role you need to have a CISSP, or they've got doc text, just template text. So, or ChatGPT's done it and I ain't read it. I keep saying, review your answers before putting it online. I would circumvent the recruitment agency and speak to them directly and ask them the question. There is nothing wrong. There is nothing stopping anybody from picking up that phone or sending an email to the individuals who are actually running that department and not circumventing the recruitment process, because you'd still have to go through the recruiter to get the job, but you can ask questions. Ask the questions. Why do you want CISSP? If it's a role you're passionate about and you want to get into and you think you could do it, but it's a junior role wanting CISSP, something's fundamentally wrong. But you've got to ask the questions. Is it not a junior role? Or is CISSP wrong? In which case, I can either argue the case for why I need to be on it or discount it and move on.
So I'm currently not in the I'm an engineer, so I've got a LinkedIn for that. Would it make sense to set up a new one, or just like botch the one I've already got?
Yeah, watch what you've got. Sticky plaster. The experience that you've got as an engineer translates. You just got to think about how it translates. Okay? Were you talking with clients? Were you talking? That's soft skills, right? Customer service, all that kind of stuff. It works. Being an engineer, putting stuff together, you know how the network works. You know how it all talks and how it all links together. From a red teaming perspective, that's amazing, because then you can go, right, that type of organization is probably fixed together like this. Transferable skills. So no, don't start a new profile, because you need all your history and you need all your prior posts and you need all of that. That's you. That's your online persona.
Problem is the network have already got things in, isn't it?
Start adding pen testers. Start adding. Use the tool to start building your cyber network as well. Because you're starting on this journey from fresh. You're moving skill set. So you're going to have to start building that network from scratch. But you might find that people that you're connected to with engineers are also connected to as a third hop, right? Or a second hop. So you could potentially leverage that to say, I'm connected to him and I'd love to connect to you because I'm looking to get into this industry. That's why I'm trying to do this. But what you'd have to do is go back to your profile, look at the content, the subheading, the about me section, all of that kind of stuff, and tweak it to be more into the cyber realm. Happy to do that with you as well, if you want to give me a shout. You're going to have a difficult one for me. Can't sit there silently. There's still plenty of time today.
Do you have any suggestion for already like who are experienced in cybersecurity to have a better approach with LinkedIn? Like I know that all of this what you have mentioned is also applicable to us, but
Yeah.
Especially about the post, I'm always worried like what I'm posting, if it's related to my work, will my employer be unhappy about it? So there is always a
Are you working for one of the big four? Are you working for a multinational? Okay. Check the T's and C's in their contract of employment. I have recently, and for me, the guarding is, it's my social media, it's my online persona, that's my profile. My employer cannot touch me for it. My opinion's on there, and you should be able to caveat somewhere on your profile, my opinions are my own, right? That kind of caveat. But I have seen recently a couple of organizations starting to put into their contract of employment that your social media, because you post about the company you work for, is therefore an affiliate social media profile, which means to a degree they can put some caveats about what you post on there. So be careful about what's in your terms and conditions and contract. Go and have a review of that. If there's nothing in your contract, then don't post anything that's directly relatable to your organization. Talk about it in the whole. My company got done by CrowdStrike. No, don't do that.
Let's say if I have an experience of a certain tool which was purchased by my employer and the experience that I'm getting is because of my employer now.
Yeah?
So if I'm adding any information about that tool on the LinkedIn profile, is it
So what?
okay to be posted?
So what? So are other people. Other people will be doing the same thing. It's a tool, right? Commercially available, not written in-house bespoke.
But let's say if I have created a workaround and if I'm posting about it, that I have created this workaround because this tool doesn't have this, but this may cause some other problems, like if there is some external entity
Yep.
which may take advantage of it.
Yep. I would probably liaise with the manufacturers of the tool somehow first to make sure that there isn't some weird license agreement thing where you've got a workaround that you're not allowed doing based upon the licensing model that your organization's got. That would be the caveat. Your workaround, they need to check and validate that it's not opening vulnerabilities that can be exploited by malicious threat actors. And at that point, if it's all good and everybody's hunky-dory with it, post it. There might be other people in the same industry as you that are having the same problem. So you've got a solution. But just make sure that you aren't opening yourself up to some kind of legal action. Got to be careful.
I don't have a question. I just wanted to add something regarding she asked about searching about the job. There is other two ways. One is following the hashtag. Another one is if you're looking for the particular company, some of the big company, if you look on the page, you see that I'm interested. Press that button. So if any job available, it appear in your page. And also, again, I emphasize to what Alex said, networking. All of my job I got, I never fill any application online. I got the job via LinkedIn. People.
Yeah. 100%. Yeah.
The events are good.
Events.
That's what I mean. Still just checked you out. You know a lot of people that I know.
Yeah, I get about a bit, mate.
There is some sort of regulation rules. They post it on the ad, but I have received some message. Also, are you looking for a job? We open some job opportunity. So if the people knows you, if the people, as he mentioned, remember you,
Yep.
then reach you.
Yeah. I mean, I don't go around wearing Hawaiian shirts just because it's a fashion statement. No, people remember me for it. You see me coming, right? And can avoid me accordingly. Any other questions? Again, I come back to this is getting child as an approach. I genuinely think what we're doing here is we're creating a problem for employers. Because at this point in time, when you've got your 3 years experience, they go, but it's not industry experience. You go, yeah, but what's experience then? Oh, well, we want 5 years. Okay, well, now you're changing the goalposts again. And you're doing that not for our benefit and not for the industry's benefit, but for your own benefit because you want somebody to start with you day one that you can sell off because they're a cost center to you. That's not building security in the right way.
How can we include though? Because I say a lot of people find it hard to find people for jobs. And then they
It
go,
should do. But this is for junior roles, don't forget, right?
the junior roles are the ones that, if this company's smart, they want to fill in those gaps first.
Yeah. But a lot of companies though want seniors, and that's why they put that 3-year caveat in there because day one they want you to start with a job and test, not be brought in and ramped up because there's a cost center to them that you will form. This is breaking that, making that problem worse for them because then they're going to have to go, well, we want 5 years, and then everybody will just go, right? So it's being tested. It's not proven yet. But I genuinely feel like this is the best route to market, aside from changing the degree curriculums at universities to make it more practical bound, which you can't do because it takes 5 years to ratify the curriculum and then publish it. And by that point, we've all moved on. Any other questions? We're running out of time, I think. 10 minutes. Yeah. Any more questions? Cool. Well, I'm going to say thank you very much, everybody, for being here and being at the talk. Please do connect with me. Please do chat with me on LinkedIn. Happy to help anybody who wants it. Ask the advice. I'm here for you guys. So warm. Thank you very much for being involved.
Anytime.
Question?
Yeah, so obviously, like I said, I'm an engineer.
Yeah.
I've been an engineer since I left school. And I'm just starting I'm just doing a cybersecurity degree at Open Uni.
Yeah.
So it's 6 years. I'm 35, and I'm just like, I'm too old to get into India. Especially because, like you were saying, that you need the experience.
Yeah.
And I'm struggling to work out how to get that experience.
Can I just say, you don't look that bad, mate, so you've got time, don't worry.
But it's like, how do I get the experience and do the uni course and work full time with overtime and then expect my wife to do me?
Yeah, you don't is the word.
Right, okay.
You got to pick. What's the word here?
The balance.
You got to pick the balance. Yeah, certainly. And also think about the channel that you want to go down. Right. It's a long conversation. We've probably got time for here.
Yeah, I appreciate
but also, still recording. Oh, okay. Take it out there. Yeah. Pick the channel you want to go through. Think about how something's a time.
Does anybody remember me over? I'll mention something. Yeah, cheers, thank you. No worries. Sorry, the name. I'm not sure the figure or what else.
You should go down the road and figure it out yourself. But I think I can give you a little bit like what that sounds like.
Research, yeah.
So maybe talk to research from close if you want to explore that further. Or this. So give you options.
Just check and make sure there's no. It's 11 to 12, 12 to 1, and then lunch. Sometimes some events you've got all 15-minute breaks. This one I don't have to remember, so it's just a lunch break. Yeah, let's just so I've literally just changed the thing on the to show it's the didn't pay event. How you doing? You well?
Yeah. I take it. Is this the
It's going to be Yusuf
CPU?
next.
Yes.
Yeah, Yusuf next. Yeah.
Yeah,
that
how
one.
is this not this year? It looks
Interesting. Finished early, so but yeah, it was pretty busy the last one, but yeah, just focused just moved on. There's extra time, so we'll get a call.
Oh yeah, there is.
Yeah. May as well.
Keep hydrated.
Actually, I might go back in the car. science by any chance?
Oh yeah, sorry. I was gonna come back.
I just thought.
It's too late, but I'll go after. Oh really? Fair enough. It took me a while to find the uni, which is ridiculous considering yeah. I actually walked onto the train station somehow.
Yeah.
So obviously it's a big That's what I did. I walked around it so many times. Oh my god. Oh my god. I think it was like 10 minutes. So I arrived I was just looking through my house. I've got I never thought of
Literally which serves as a hand.
yeah. Another one which I still haven't opened for much yet. Is that the North East? I don't know what it is.
So what?
Smack. So yeah, that should just go straight in. You wanted the mat today, so she wants it.
Will it come up right away?
Yeah.
Oh, okay, cool.
Very slowly they died. And then it was like it was in the house and it was like overwintered, so it like got very
That's so anti-climactic. Oh my god, I didn't even my hand is like this now. Because yesterday, so I had my hair done this morning, and obviously like being up for hours now, so just
Got the wrong hand.
When you've written it, it's not hard to see the
They can read.
So from
That's
here,
like yeah. So this is kind of what we're seeing.
Oh, okay.
So I can follow you nicely, but any more further up, I can really work up.
Yeah, don't worry, I'm not gonna make it that hard. It's definitely fine.
Yeah, just let me read it.
I was going to say, because the other talk about like the SteelCon.
So like unlike a tabletop. But like a tabletop. Any good? Yeah.
I was just saying like some of the
Oh yeah. Yeah, I've heard just experience.
Hello. Hello, can you hear me clearly? Okay. All right, great. I'm Yusuf Hussain. Thanks for coming to the talk. I'm a little bit nervous, too many people here. If I say something absolutely stupid, please correct me. Feel free to just, hey, stop me there. I'm a security engineer at Google, and I've been with Google for a little bit over a year and a half now. Before joining Google, I was working at Apple for quite a while. And in the past, 7 to 10 years, I was focusing more on incident response. Like, oh, we've got bad news, we got hacked, what do we do about this kind of stuff? So I did a little bit of work around malware analysis, reverse engineering, but also incident coordination, forensics, that kind of work. I worked at Apple doing this a little bit, and then after that, I joined Microsoft. I did a little bit of that at Microsoft. And then I joined Meta, Facebook Meta. I did a little bit of that as well. And finally, Google. The reason that I joined Google at the end is because they just kept rejecting me. So I was like, I might as well just try the other folks and then come over. And at the end, they were like, oh, gosh, this guy keeps applying. Come on, all right, come in. We'll just figure it out. So now my role is a little bit different from what I've been doing within the past like 7 years. Incident response, its focus is more on like exploitation, vulnerabilities. What do we do about vulnerabilities that affect Google products? And I'm part of basically 2 teams. The first one is called the Vulnerability Coordination Center, which is the one I'm going to be focusing the talk on a little bit. And then there is the Bug Hunters Vulnerability Rewards Program. Some of you might know about this, is if somebody finds a bug in Google Cloud or something, they report it to us, and then we would work through it and fix it. The first one focuses more on like the big vulnerabilities, the disasters, the kind of like, hey, if somebody figured out how to shut down Google search, what do we do about this? Kind of stuff. This is the Vulnerability Coordination Center. This one is like smaller things, like somebody find an XSS or a CSRF attack vulnerability vector on a web page that we own, and then we fix it. If it escalates and becomes like a very, very big thing, then it could go to that team. So I'm the only one at Google that does both. I do a little bit of the small ones, I do a little bit of the big ones. Sometimes I escalate to myself. Yeah, Yusuf, the other guy, do this. Anyway. So Vulnerability Coordination Center, what do we do? Let's say that, for example, somebody found a way to shut down Google search. DDoS globally. It comes to us, and then one of us in the team would lead the investigation, the response, and the coordination globally across all of Google. There's like about 12 of us globally, and we're spread around the world to basically cover the whole globally and then have a follow the sun kind of model. I'm based in Germany, and my friends in the team, some of them are in the US, and the others are in Sydney, Australia. The other thing that I do a lot of is software development. Sometimes I even forget that I'm a security engineer because I do a lot of automation work. So we do responses to vulnerabilities, we do fixes, we do things like that, but is there any way we can be more efficient? Can we just make the computer do it for us, kind of stuff? And then I would write a program that would do this for us. So this is the kind of work that I do. A response story. So I'm just going to go through an actual scenario that happened. And I was basically the global lead for it, for Google, to basically go through it. It was very exciting. I was also fairly new at Google. Somehow I was like, hey, Yus, if you're new, you're excited about using Google, right? There you go. Here is one of those toys you can play with. I'm just going to go through this. First of all, I'm going to have to talk about a couple of things. And some of it might be a little bit confusing, and that's fine. There are 2 CPU features. You probably haven't heard of them. I actually haven't heard of them a long time ago. One of them is called ERMS, and the other one is called FSRM. These are optimization features in the CPU. Like sometimes the CPU instructions would say something like repeat and do this instruction, and then it repeats and it's done multiple ways. So there is an optimization feature in the CPU that makes that more efficient if it's done again and again and again. So that's what ERMS is first. The problem with ERMS is that the CPU has to do some form of like setup, and if the data that you're actually working with is under 128 bytes, then it's not really worth the investment, so it becomes actually more expensive to just do the setup, so it's not worth it. But if it's more than that, then it becomes cost effective, and that's what FSRM is. ERMS, I think, is short for enhance, repeated, move, short, and this one I think is fast, short, repeat, move. I have no idea why they came up with these names. I'm sure these are brilliant people that work with all this stuff. I'm just not sure why they struggle with coming up with better names. But anyway, I don't know, like there's a lot of names that I just find them very easy to remember, but these are just some of the few that I just always forget. But anyway, now we understand this. We're going to get back to this in a little bit. Move EAX, EBX. This is, you don't have to worry too much about what this means in details, but it's basically an assembly instruction. So now if you compile a program and you run it on a computer, it's really basically just a series of bits, right? Zeros and ones. Now if you look at the zeros and ones, how many of you could actually look at it and be like, oh, that's a print statement? I mean, not a lot of people can do that, right? I can't. So what you can do is you can basically transform that with a disassembler into a way that is more human readable, that looks like this. So first time I looked at this, I was like, that didn't help too much. Like, yeah, still, I don't think a lot of people are very comfortable reading this. This is supposed to be human readable, but I don't think a lot of humans would like to read this kind of stuff. But anyway, this is just an assembly instruction that does something basic, which is basically moving data from a source to a destination, from a register to a register. And this is another assembly instruction that does something similar, which is also moving from a source to a destination. But as you can see, it doesn't have the operands to say where you're moving to and from. Because this one is a little bit different, it's the operands are implicit. You do a setup before, and then you run that instruction. And then the CPU would know what to do. And then there is a repeat before it, which basically means do it multiple times until this counter at the top goes to 0. So one thing I just want to go through is the way that the decoder for these instructions in the computer will work is that if you add a prefix like repeat is a prefix, tell it to repeat. And if you add another one before it that doesn't make sense and it's not needed, it will just ignore it. It's not going to break anything. It's just going to ignore it. It's like, oh, I don't need that. I'm just going to ignore it. Same thing happens. You could just do as much as you want. It's not really a big of a deal. And one final piece I have to go through is, back in the days in 32-bit machines, we had 8 general purpose registers in the CPU. So the decoder in the machine had to take that into account, and then they basically decided that the operand would be 3 bits, because 3 bits would be enough to basically specify 8 registers by name. So to the 3 bits, like 8. And then later on, we had 64-bit machines, which had 16 general purpose registers. So they were like, what are we going to do about this? Well, there is a way to fix it, which basically make this more readable and, do something reasonable, so make it work, right? But they decided to hack it instead. So what they did was, we have these prefixes that could be ignored. How about we could just have a prefix we don't ignore? We could basically just borrow a bit from it, then we have 4 bits, and 2 to the 4, you end up with 16 registers. So that works. That's what they did. And it's called REX, which I think is short for register extension. So something like this would just basically mean, hey, we can borrow a bit from REX for this particular instruction. Does that make sense? So of course, that's going to get ignored in this case because this particular instruction doesn't need that prefix, like I said before. However, there is a certain scenario in which this would not get ignored and it will cause a problem. Based on what I've said so far, can anybody tell me what kind of systems these are? I was talking about some features earlier. So basically, if you do something like this in a system that supports FSRM that I mentioned earlier, which is introduced in Intel Ice Lake CPU families, this could cause a problem. So this is what happens. You've got REX, which should be ignored, plus FSRM, you get into a problem. How did people figure this out? So we have researchers at Google. All they do is finding bugs, interesting ones. And sometimes they're CPU bugs. So what they do is sometimes they would basically get 2 identical programs. They basically do the same thing with the slight differences in characteristics. And then the expectation is they would basically produce the same output. However, for those of you who are familiar with exploit development, a lot of times what we would do is we would basically just observe the machine state when you do things differently. And then if it changes, that could indicate that there is something bad about the system, especially if it crashes, because not a lot of programs are designed to crash. So if you take a normal program and somehow you fuzz it or play with it and it crashes, chances are you found a problem. This is like a milestone for exploit development. I crashed it. That's good. I hijacked the program. So let's see if I could do something a little bit different than crashing it. And that's what happened, basically, in this particular case. And then this vulnerability was published, which is Reptar. Some of you might have heard of it. It's an architectural CPU vulnerability that corrupts the instruction pointer by running a sequence of assembly instructions which results in unexpected behavior and bypassing CPU security boundaries. Now, Intel CPU, when you run these instructions, the way that I described and crashes or gets in an out of service state, we don't actually get to see much of the details of what happens behind the scenes. It's a bit of a black box, but Intel knows. So we reported this to Intel so that they can look into fixing this. And then when they looked into it, they said, well, you can't only do a denial of service, you can actually escalate privileges too. But that's not a big deal, right? It's not. I don't think it's a big deal. I mean, do you think it's a big deal? Like, I mean, right now we have like racks with servers, and you SSH into them. You install Apache and the OS yourself, and everything is isolated, right? Right? No, right. Yeah, we have like this scalability now. We have this cloud stuff, right? We have the elasticity. Everybody shares everything with everyone else. And one of the things that the researchers did was when they tested this particular vulnerability in a machine, in a VM environment, guest VM, it would basically cause an MCE, machine check exception, on the underlying host machine. So that's when it got a little bit interesting, right? Like, can anybody tell me an example of a product or a service where this could be really interesting for an attacker to just go and they just shut down everything? Thank you. Yeah, that's the perfect. Actually, that's probably the best answer. There are some others, but that's in my opinion, the number one. Yeah, yeah. I mean, when we're talking about this, we're like, Google Cloud, guys. Before we continue this conversation, let's come into this room and try to figure things out quick. So we've got cloud, like I said. So at this point in time, what we did something called an impact assessment, of course, and but we do have a very streamlined, specific process at Google with which we do an impact assessment, because Google is very big, and we have to very quickly, sometimes within a day, figure out where are we impacted across all of Google, and that's not just Google products, but also the internal systems that Google uses within Googlers themselves. So we did the impact assessment, and of course, the first thing that came up was Google Cloud. Why is Google Cloud a problem? So this is how it looks like. You get an attacker VM in Google Cloud because, you don't actually need permission to run something on Google Cloud, right? You just go create an account and run a VM. And you're already sharing the physical machine with everyone else. And the assumption is that you can't actually interact with other people's VMs. You run WebTar exploit. You cause a crash on the host machine, and that basically ends up with crashing the other VMs by other customers that are running on the same physical machine. I would be really surprised if somebody tells me what this logo is for. Wow, it is Borg. It is Borg. Wow. Okay, Borg. So, does anybody know what Borg is? Oh man, I was going to talk about this and you ruined it. I'm just kidding. So, all right. So, a little bit of a history. So, back in over 2 decades ago, I think it's 2003. Google was like, well, we need to really manage these machines more efficiently. We can't just give servers like that. So we have like a cluster of machines, how we can efficiently basically divide it based on needs of the applications that run on top of it. And then we can basically control the workloads in containerized environments, right? So they did that back then, and it was needed for Google, obviously. And basically, the way that it works is that at Google, we've got these big, massive data centers. In the data center, once you go zoom down a little bit, you've got like the clusters. There's something we call a cell, which is basically a cluster of machines within the data center, and each cell would have a master, which is a Borg master that orchestrates the setup of applications in different containers within the slave machines within that cell. And for example, I run things on Borg myself at Google, and I don't actually have to go to the server and do anything. Basically, I just tell Borg, hey, I've got this binary, I would like to run it, and it needs these resources, and it would just take care of it. It also had a feature called autopilot, where basically you would look at my application and the way it runs, and it will decide on my behalf, oh, this actually needs this amount of resources, or just run it for you. And then later on, this was basically the origin of something that is public, which is not you. Anybody knows what is public and everybody knows that does something similar, orchestrates containers? Yeah, Kubernetes. Yeah, so that's pretty much it. So what is the issue in Borg in regards to the vulnerability that I was talking about earlier? Is it, maybe it's not a problem, huh?
Isolated container can shut down all the containers.
Yeah, yeah, it's kind of similar to the cloud scenario, right? So we call this shared Borg because at Google this is all shared. And at Google we run everything, pretty much everything up in Borg. Everything we run is on Borg. And then we've got the last piece, which is, what is this? This is easy, Google Chrome OS. So these are client devices, and they're also affected by this particular vulnerability. But for clients, it shouldn't be a problem, right? Because on clients, you're not sharing anything. It's your own laptop. And there's no way you can exploit a client in a vulnerability like this, right? Right? I was looking for another answer, but good one. So, I mean, if you think about it generally, would you think this is a feasible attack vector on client devices? Yeah, yeah, yeah. It is possible. At the time, we couldn't immediately have a proof of concept, but in theory, it is possible. Until today, I'm not really sure if somebody came up with a proof of concept for clients. But server was easy. So how do we fix this? Clients was a bit of an easier journey because, okay, there was an update that was provided, and then we basically published to the client devices. And the server side, it was a little bit more complicated. There is something called the chicken bit. The chicken bit is basically a bit in a CPU that you can flip to disable certain features. Like, for example, the FSRM feature that is causing basically all of this shenanigan, you could disable it by setting that bit in the CPU. And I think they called it the chicken bit because it's like, oh, there's a new feature here. If you don't like it, maybe you chicken out of it. Like, I don't know. But yeah, so it's a chicken bit. But it's definitely better than FSRM RMS, right? It's a better name. But there is a problem with the chicken bit. It is something that we could basically flip in all of our server fleet, and then we mitigate this vulnerability. But what do you think could be the problem? And don't look at the slide, or maybe you already did. But why do you think it has a high performance impact? Does anybody know? Exactly, yeah. That's what I said earlier, right? It's basically an optimization feature, so we don't have to forget that. Once you disable it, wow, the impact, I think, was about 10%. And you can't go and say, hey, Google Cloud guys, we're going to go down a little bit 10%. Like, it doesn't work, right? We can't just do that. And then there is, of course, the microcode update, which is an official update that becomes available from the vendor, which in this case is Intel. And they did provide an update, but then there are like two ways you can do this. You can do a BIOS update, which basically means you're going to have to restart the machines. And if you do this in an environment like Google Cloud, it's not a simple thing. But there is a cool way you can do it. You can hot load it, which basically you can update all of the machines transparently without making any effect. And that's what we did. We actually did an update for this for all of our machines globally, including Google Cloud, transparently. And it was pretty successful. Now, when you say transparently, it's not 100% transparently, because it's like, if you really monitor the cycles, there's a bit of like a brownout effect, but it's not something that you could notice in terms of like how the application runs. So, IMAG. IMAG is short for Incident Management at Google. So at Google, because we have a lot of situations like this, and Google is pretty big, we have to really have some form of a set of protocols. When you're doing incident management, we can't just say, hey, there's an incident, let's figure things out now during the incident. So we have something called the IMAG, which is based on the incident control, incident command system that's already used by firefighters and medics, which is basically just a way. It's a program that basically gives you a standard of how you can run an incident and how you can organize a team in a hierarchical fashion with clear roles and communication channels, so that you don't have to think about all of these things during the incident and you're panicking. So we have to follow the IMAG protocol. And in this particular incident that I'm talking about here, this is how it looked like. And in this case, I was the boss. I was incident commander, but anyway. These are all like leads. By the way, this is not every individual that was actually assigned the task. These are the leads across Google. Under each lead, you could have teams working on different things. Like, for example, Google Cloud Response Lead, they have Cloud team that have to do things like, for example, applying the fix properly. Same thing with Chrome OS. Then you've got the communication lead that had to deal with like communications. Why do we have to deal with communications or legal or anything or any of that thing at all? It's just applying a patch. Can anybody tell me why that's needed at all? Who are we communicating with? In case things go horrible wrong? Yeah. Yeah, that's one sinner. Yeah, that is correct. So we had to develop something called an internal FAQ, frequently asked questions, and we had an external FAQ. If a customer has an issue, then we prepare our external facing engineers with the answers so they can respond to them. So these are some of the things that we had to do. But also we had to prepare things like, what if the vulnerability gets leaked during the response? We actually haven't patched everything. Because this is pretty big. We have to make sure that we're controlling access to all of these details. Because if it gets leaked, I'm sure a lot of people would be really interested to know about this before it gets fixed. So we had to prepare something called reactive statement, for example. Like if this goes out and people ask us, how are we going to respond to that, for example? Of course, legal has to approve for things. And then we've got corporate systems, like internal systems that are also affected. How do we fix that? We have a team that had to lead that. And then at the top left, you see non-Google Alphabet response lead. What does that mean? Does anyone know? What's a non-Google Alphabet? Yes, exactly. So, for example, we had, I don't know, Verily, had Waymo, self-driving car, a bunch of other interesting things. One thing I want to mention is that when we were dealing with this incident, we had an embargo period, which basically means this has to be kept secret. We can actually publish and talk about it outside until this embargo period ends. And we couldn't actually share it with the rest of Alphabet companies because that NDA was signed with Google. So we had to make sure that, okay, we can address non-Google Alphabets later on after the embargo period. So how did it go? This is how the timeline looks like. The response embargo period at the top. From the discovery, and then we did the impact assessment like I described. We had the microcode tested, applied. We did that on Chrome OS and server microcode rollout, and then disclosure. We had to prepare something called a security bulletin, which is basically telling, for example, cloud customers, hey, there was this vulnerability. Here's a security bulletin for it that describes what the issue is, and we've already fixed it, kind of thing. And then at the end, we also had to publish a tool called Icebreak, which is basically a tool that you can test any machine that you have, and then basically figure out whether, are we affected by this vulnerability in this particular machine or not. It's called Icebreak. And then later on, after we're finished, everything is done. I was thinking maybe I'll go to Hawaii and just relax. Somebody from the public sent us this message. Hey, just heard about Reptar. I tried running the Icebreak tool on Cloud Shell, and it worked. Yeah. Would anybody be shocked by this or surprised or worried at this point in time? By the way, this is after everything is finished. Yeah, especially for me, like I was running this incident, and I was like, come on, like maybe I'm dreaming. But yeah, so turns out at the end, when we investigated this quickly, that the Icebreak tool had a bug. Yeah, it was basically telling you, hey, freak out, please. But yeah, it turned out that systems were actually passed and everything, but sometimes the tool wouldn't give you the right information. But yeah, so that's what happened there. So what did we learn from this? And so, for example, when I mentioned about the iMac stuff, it was very evident during this incident for me specifically that, okay, it was very important that we actually had to follow these protocols because this incident was pretty big and it was very busy and we had to basically make sure that we have a proper structure we can follow. What can we do better? I think in my opinion, there's a lot of manual work And for a company like Google, it's you really have to kind of automate as much as you can. I think we could have done that. Can we automate? Like I said, of course we have to automate. A lot of opportunities for that. Are we prepared for the next one? Depends. But I think we kind of are. This is something I just wanted to mention at the end. It's one thing that I've actually been working on recently is that when there is an incident, we have to create a team. We have to create a set of artifacts like the ones at the left in terms of communication, for example. And then we have to produce a lot of artifacts and do a lot of other things that we've been doing manually. And also the process was not great, I would say. It's not perfect. So I thought it would be really important that we could produce a process that is very streamlined and easy to follow for anybody who's going to be an incident commander for an incident like this, but also automate the process. So basically, I'm working on a project where if there is an incident, then basically communicate at Google to the right people, hey, there's an incident, we need to fix this, and these are the artifacts, here's the incident commander, let's start working on this, and focus on the important things, and don't focus so much on the process itself. Focus on the interesting, fun stuff, as opposed to other artifact that is just going to keep you busy and distract you. So this is just the story of the incident, and I thought it would be useful to maybe leave a little bit of time for questions.
Hi, Yusuf. Thanks for sharing. That was really interesting, particularly given the sort of technical context. I really appreciated that. Could you go back to the previous slide where you had the hierarchy? Yeah, you mentioned your role as global lead, I think. Where does that sit on here? Could you share what your, right at the top, again.
Incident commander.
What was that? It sounds like quite a lot of responsibility. What was your experience like? What sort of skills did you maybe learn, lessons learned personally?
Yeah, that's a very interesting one, and I'm gonna be honest with you. When I was doing this for the first time, I was like, "Can I do this?" But I cannot say I can't because I got the job, right? But anyway, so first of all, as you can probably see, this isn't only technical. So of course I have some of the technical background, and this is the stuff that maybe I enjoy more. How do we fix this? Looking at the code and CPU stuff, how can I run the exploit myself and try it? Oh wow, it worked. But then of course there's like the communication stuff, the legal stuff, and all that stuff. I had a little bit of experience with this because before that I had to deal with a lot of big incidents as well, even at other companies. But I can admit that it's not my greatest areas. So I'm still learning how to do this kind of stuff. But one thing I did which really helped me in this is that I did a lot of delegation. Like for example, as an incident commander, I had to learn to delegate a lot. Communications lead, I was basically telling him, hey, you take care of everything communications. And the only thing I want from you is when I ask you how's it going, you tell me it's going very well. Same thing goes for the other ones as well. Operations lead, this was a very, very critical role. This is somebody who's super technical, and he's very familiar with a lot of the infrastructure at Google and their details. If you ask him any technical question, he's expected to just answer it right away before you even complete the question. He knows a lot. And even if he doesn't know the answer, he knows who to ask and get the answer. So, of course, we had to get somebody who's really good at this to basically do the operations lead. And there was a period in time, he was on holiday, and I was covering operations lead and incident commander at the same time. Luckily, nothing happened. But yeah, and then tech research lead, for example, is the role of the lead who basically had the researcher that reported this vulnerability. I don't know, some of you might have heard of him, is Tavis Ormandy. Yeah, so he's the one. He's actually in a partner team and work with them. And then, of course, you might have heard of Google Project Zero. They do find some interesting stuff like this as well. We also partner with them. They're a partner team. But yeah, does that answer? Thank you.
Well, I'm guessing it's all like nice and contained when you have to fix your own service. But how do you communicate? You discover a problem. How do you communicate to the outside world? How do you propagate the knowledge of the problem? Like other companies, what's your experience? Because I'm guessing some companies like probably don't care, or do the virus updates and stuff. How does it look like to propagate the?
Yeah, that's a very good point. That's a very, very good point. If you look at the top right, there's vendor engagement and tech lead role that engages with Intel. So this is the person that interacts with Intel and makes sure that, okay, the communication with Intel is proper. We can tell them what we need, and they can ask us what they need, and we can work with them. Behind the scenes, we were working with Intel to ensure that other big industry partners are also working with us. So when I was talking about this part here, microcode tested, PV means production validated. This particular period, other partner companies also knew about this. It wasn't just Google, like Amazon, for example, because of course they've got AWS. So what happened was that these big industry partners, we worked together to basically all test this microcode update and make sure that, yes, at the same time, before the embargo ended. But of course, it's like a contained set of companies, the ones that are really affected by this, the big cloud providers kind of companies, which it makes sense, right? And then after the embargo, it would basically be published to everyone else. But of course, after the embargo, when things are published, everybody should be able to look at what's published and fix it immediately.
Yeah, because I was wondering, how do you tell people who need to know and keep it away from people who
Yeah. Yeah, that's an interesting problem. So there is an NDA with all of these companies, Intel and that company. And even within each company, it's not everybody knows. Like just because Amazon knows or Google knows, it's not like everybody at Google knows about this. Like I can't talk about this outside of the incident and the incident response team at Google, even to my teammates. So you have to follow what we would call, like, I don't know, need to know. I think this one was, what is it? TLP red. So yes, we have to follow this protocol. Now, does that mean it's perfect? There's a potential for leak, and that's why we had to do that reactive statement thing that I told you earlier. We have to prepare if it gets leaked. We also had, there's something important I want to mention. We have partner team that do detection work. For example, to look into, how does this attack work? Is there any way we can detect this if somebody attacks Google? And then they would basically look into the detection capabilities and see if they can detect it. And then we work with them before a lot of this happens so that we prepared, okay, if this gets leaked and somebody attacks us, can we detect it? In the case of CPUs, it's very difficult sometimes to detect things because we're not talking about like web logs or Windows event logs or anything like that, right? This is way, way lower level. But there are ways you could detect it, but it's not very easy. Yeah.
How long did it take to do the microcode rollout, and was there a potential for that to be discoverable by people whilst that was in progress and therefore it was exploited?
Yeah, that's a very interesting point. There was a process we had to go through, and during that process, a lot of details. Like, for example, when you push code, you have something like, for example, GitHub, and you have to describe, this code is going to be fixing this, because of that, and then you have to control access to that. Now, we had to do something similar to this during this incident, where we have to basically make sure that we obfuscate everything, so not nobody could tell what this code is for. And there are ways you can do this without a lot of people being able to see it. Now, I don't know if this is what you're asking, but if you're suggesting there's a way you can actually deduce what the vulnerability is by looking at the side effect of the server, and then the SRE or the system engineer looks at that effect and be like, I know what the vulnerability is. I think in theory it's possible, but I think if you look at it from like a risk perspective and how realistic is that today, I think it's very reasonable to say I'm accepting that risk. Like, there's not a lot of people can actually do this. Yeah, I think there's a lot of effort going on right now where people are actually trying to look at the side effect of a server, and then, can we tell if there was a patch to a vulnerability, and then we can basically tell what the vulnerability is. I don't think a lot of people have been successful in doing this, as far as I know. Yeah, no. If you have the microcode, then that's a different story. Like, let's say I tell you, hey, here is the microcode, and this is a fix to a vulnerability, but you cannot tell what it does. That's different. And it's still difficult to tell what it does, but that's a different story. You're not looking at the side effect of the applying of the patch. And of course, we had to control the microcode. Nobody knew about this microcode during this period of the embargo. Yeah. I'm not even sure if somebody tried after we published this to basically figure out what the vulnerability is just from the microcode. I'm not exactly sure if a lot of people would be interested in giving this a try, but I don't know. I would imagine it's very difficult. I wouldn't be able to do it easily, but I don't know. Yeah. So, okay. If I don't answer your question completely, please let me know. But there are partner teams, that the ones that do detection work, that we partner with them, and some of them are also included within the response. So they know about this because there's a need to know. We give them the details, and then we ask them, can you detect this? So this is generally what we do, not necessarily only this vulnerability. Like, tell them, hey, can you detect this, and can we be prepared? So if it gets leaked, we at least know if somebody tried it against us. And then, of course, on the communication level, like I said, the reactive statements and all that kind of stuff.
On a similar note, do you do any work going back to see if it was previously exploited?
Yes. So this is an interesting one, because I think it gets a little bit into kind of like fantasy world, because I like to do this sometimes. And we're like, oh, well, we fixed it now. What about if somebody knew about the vulnerability 5 years ago? And maybe it was already known before, but just nobody told us about it. We discovered it. Too bad for them. Now their 0-day stash got down by 1. But was that happening? So we do try to do that sometimes, but again, you just have to kind of balance the effort required to do it and the risk. And a lot of times we have more important things to do. We'll be like, yeah, do you want to do this? And sometimes is it possible or not? And of course, like it's not, we have a lot of things that would indicate whether your system is compromised. And it could be as a result of this or as a result of something else. So just because you don't know the vulnerability itself at a certain time doesn't necessarily mean that you cannot detect the side effect of it, right? No, because when I was doing the impact assessment, I was taking into account the fact that we can do both. I was like, oh, what's the worst case scenario? We can do both. Let's just assess the impact for this. You can escalate privilege in cloud. Yeah. I guess that's, would you have done it differently? Okay, thank you.
Just following on from that, in an incident it can get into especially when you're between the technical people, incident. There can be a lot of what-if questions. How do you deal with the constant what-ifs, taking technical people's time to look at and do the resolution while preparing the communication statements?
Sorry, maybe I didn't get the question completely. Can you say it again?
So what I'm asking is, there can be a lot of what-ifs when you're in an incident, and how do you protect technical teams from ability to do the actual work, resolution, remediation work, while getting those common statements ready for both internal and external audience goes out to move and ask, what if, what can they do, what do we put in this?
Yeah.
How do you keep those what-if statements to a minimum while giving them the ability to do the work?
No, that's a good point. So first of all, there are like two parts to this. The first part is the technical people are not actually going to be writing the statement. But if the statement has some technical element into it, then we could consult the technical people. And then we have like the communication lead, and then we've got like the legal lead, and they look at this information that we have in these statements, and they make sure that we have only the information that we need to have in these statements, and they approve it. And that's really their full-time job. Basically, it's looking at things like this and approving it. So we leverage their capabilities in doing that. Technical people don't have to worry about that. We don't even expect them to work with that too much. Just focus on applying the patch and not causing any impact. That's pretty much it, what they have to do. Yeah. I think somebody here raised their hand. Okay. Sorry if I didn't notice earlier.
Because of Chrome OS and Android running on ARM64 predominantly, do you think that Google will in-house their own silicon design, get rid of their T6 and make it all, homogeneous? And in that case, if that happened, I mean, obviously there still will be, silicon flaws and design flaws on the chips, but it would then be in-house and it would be easier to push your own microcode than relying on a separate vendor.
Okay. So, okay. I don't mean to return the question to you this way, but like if you were to do like some form of risk assessment, would you think from a security standpoint it would be more secure to basically just, hey, well then just build your own kind of stuff.
I don't think it, well, unless it depends on just selling your own silicon to other people to use, and that makes sense, and that's, public, shared, but I don't think it's any more inherently insecure. It's just would the process be a bit more streamlined if it was designed, perhaps the actual silicon would be.
It might, but to be honest, in this particular case, we didn't really have a problem. Actually, one of the things that we were very happy about is the collaboration with Intel. We had similar problems like this with AMD. Not a problem with AMD, but like problem like vulnerabilities. It was also it was also always successful. But based on the experience I've had here, I don't think I had complaints. Yeah, so that's my take on this.
So your team that found this bug through fuzzing, are you only fuzzing hardware you've currently got in use in your data center? Are you fuzzing all sorts of different hardware that potential customers are using as well?
Oh, they fuzz everything.
That's a big job.
Yeah, I don't know if I would be able to do it. I'm pretty sure that I think there are like certain type of people who are really passionate about discovering vulnerabilities, and they do this kind of work full time. For me, maybe as a hobby, I would do it like 1 hour when I had a nice Diet Coke with ice. I'm like, and then we're like, okay, I didn't find anything. I'm just gonna go to sleep. But some people just found it really fun, and they always find stuff. I find it really interesting. I like to go and chat with them sometimes and learn a little bit about what they do. But to me personally, I would find that to be a little bit stressful. Like, oh, with the expectation I'm actually going to find things and actually doing research all day long in things like CPUs. Yeah. But but like for example, Google Project Zero is pretty popular. So they do a lot of research like this across all things, and they try to identify things, and a lot of times they do find things.
How much testing did you do to get it to PV status?
Oh yeah, that's a very good point. So we did a lot of testing within Google, but also confirmed testing across companies. Like for example, when we were collaborating with Intel, we also got to know that other companies that tested, like Amazon, AWS, for example, also were successful in testing it. So there's a collaboration between a lot of industry partners. Yeah, and of course, when we tested internally, we had like a period of testing. Like for example, we didn't just test it in one day and be like, oh, it worked, it's fine. We had like a period, I can't remember exactly, maybe it was about a month or something like that. I think it was about a month, and then we'll basically just wait and observe. Because a lot of times you could see a regression later, right? Like, so yeah, so that's what we did. We had like a good period of time during that embargo, because the embargo period is quite long, right? Like, yeah. Before, like, I don't know, like a little bit after August and all the way, like after November, we had a big part of that was testing. And basically what we did was we get the microcode update, we test it, and if it works, then it gets promoted to PV status, which basically means it's good. It's not like we got a new one. Yeah.
From a third-party supplier sort of perspective, Google identified a problem with something that they've got from the supplier and then fixed it for the supplier. Do they then charge it? It seems like it's a lot of resources to take in. Do they charge Intel for the time?
So that's a good point. So in this case, the ultimate fix was actually by Intel. We reported vulnerability to them. The chicken bit idea was by Googlers, and then we determined that this is going to cause an impact. And then we kept it in the back pocket saying, hey, if we don't actually have anything else, and let's say it's leaked, and we're in the position where we really need to get this down fixed, and we can live with 10% impact, then we could use it. But in this case, the ultimate fix was actually a microcode provided by Intel. We still help them, but they did the microcode update. Yeah.
So was this embargo period decided by Google? Because I know you have the 90 plus 30 for
Yeah, there's like a standard, I think 90 days. It's negotiated with Intel.
Do you monitor Google search to see if there's been a leak, potentially?
Do we do what? Sorry?
Do you monitor Google search to see if some people are searching for the issue? To see if there's been a leak?
No. I think in a case like this, I think there are much easier ways to find out if there's a leak. If something like this gets leaked, people will know, right? I think it's a little bit difficult. Not know. But also, we have a team some of you might know of TAG, threat analysis groups. They're quite popular. There's a team at Google that basically does threat intelligence. They also get engaged in things like this, and they would monitor the internet generally and look for signs of things that have leaked and things like that. They can actually help us, or somebody talking about this vulnerability, or the vulnerability got leaked, or the vulnerability is being exploited in the wild and things like that. Yeah, that's how we do it.
How long did it take Intel to actually produce the microcode update?
Maybe you can look at it here. So a little bit before September, here we got a microcode update tested and gate production validation just before October. Oh, the microcode update was here. That's a little bit after September, so that's like about a month maybe.
But it didn't say when you reported it to Intel.
So yeah, so August we immediately reported to Intel. So you could assume that's when they started working on it. Yeah. Okay, maybe one or two more questions. It's not just the ones who's cloud. They're like big industry partners. I can't remember the exact list, but I remember at the top of my head AWS, because of course AWS. Yeah. Yeah, I think it's like AWS, Microsoft, Intel, AMD, and some other industry partners, and it's like a circle. But it's not just because they're cloud providers. So so of course, when we do the impact assessment, we get to assess the impact generally. But in terms of actioning this now, today, at the beginning of the incident, that was something we had to do within Google. Yeah. But of course, like for example, when we assess the impact and we know that this affects Google because it's cloud, and you can shut down the host machine, then yeah, there are a lot of other clouds in the world that we could assume are also affected. Yeah. Okay, maybe one more question. You're like, I got it.
When you actually execute the vulnerability, you said it shuts the machine down. Is it just off then, or does it reboot itself?
It shuts down. It causes something, it basically halts. It causes something called the machine check exception. Yeah. Yeah, you could basically just keep spinning up VM. Yeah, you could basically, yeah, that would be a very fun way to do it, right? Just write a Python script. They're just going to go across. Just open a VM, shut down, and then, I don't know. If you do this, maybe you'll get something in the news like the one we got yesterday. I don't know. But, okay, that's it. I hope you enjoyed it, and I'm going to be around during lunch outside, and if you want to chat, feel free to reach out to me. But yeah, thanks a lot.
Do we like close the? Oh, there is a.
Yeah, I think they're filming. The guy stands at the back and he films.
But can you ask how do you connect the thing?
No, I don't. I have to find.
Not sure. I've got the adapter actually.
Yeah, you need an. Oh wait, there is You need an adapter.
Do you want? I don't know.
Cool. Can everyone hear me? Yeah? All right. Awesome. So firstly, thank you everyone for being here. I know it's post-lunch, everyone's a little bit sleepy, so we're going to try and make it fun and quick. Yeah. And welcome to our talk, Elevating Red Team Payload. So we have divided this talk into 4 parts. We're going to do a quick round of introduction, and then we're going to start talking about why this talk. So how did the idea came about? What was the intention of it? And then Victor is actually going to walk us through the actual research work that we have done. And then finally, we'll have a look at the outcome and any sort of learning we had, any future ideas, and so on. So I think I know of quite a few people in the room, but for those who don't know me, hi, I'm Dhruv Bisani. I currently head the adversarial attack simulation team at Starling Bank. Been in this space for 8-10 years. Previously, I was a head of red team at a company called Resilient, which is a consulting company, and my last couple year focus has been delivering red team, developing payloads, and looking after the team really. Have some experience in CBEST, TBEST, regulated testing, and a few different sectors. Last year, I've had a pleasure to speak at a few different conferences as well, and that's me.
Hi everyone, my name is Victor Vanderhelm. I'm a senior red team operator at Starling Bank. So I have a keen interest for malware development, and I come from a pen testing background. Lately, I've been focusing on researching cloud technologies, working with infrastructure as code, and doing macOS research.
Thank you, Victor. Actually, you can do this. It's too hard to have more. All right. Before we start, a quick disclaimer. So we are not here to discuss anything groundbreaking. We're just going to talk about how some of the ideas that already exist in the industry has helped us to develop something that help us become a better red teamers. We are not expert. We are just here to share our experience. So if you do have any idea, suggestion, or even a correction, feel free to talk to us after the presentation. More than happy to discuss this. And lastly, the aim of the talk is not to give you something that can defeat every toolkit out there or every security toolkit out there, but rather something that can help you elevate your payload creation process. However, I do hope you enjoy and learn something, and something that helps you, implement or better your own processes as well. One last disclaimer, while we both present and represent Starling Bank, there's nothing in this talk that actually relates to Starling Bank itself. So yeah, there's no similarities between what we talk and the bank itself. Cool. So why this talk? I think everyone here who has done red team for a while has seen this problem, that us as a red teamers spend a lot of time writing payloads, debugging it, making sure it works. Once you have the base technique that works, then you go into OPSEC modification, you make sure you add encryption, garbage code, X, Y, and Z, make sure that works. Then you perform OPSEC check, so you make sure your payload is not disclosing anything, not leaking information that is not supposed to, and then finally you have something that works, right? A lot of this is manual work as well. However, all of this kind of goes to waste when your payload is actually detected. Now this can happen at any time of the project cycle, so it can happen even before your project starts. It can happen during the project, or it can happen post-project, especially when the blue team takes the payload, submits on different forum, gives it to CrowdStrike, Falcon, they rip it apart, and so on and so forth, right? So we have seen this problem quite a lot. Now this is what our payload dev cycle looked. Can I have the pointer? Thank you. This is what our payload dev cycle looked like. So usually you would have a technique that you want to implement. So you write a base code for it, and then you make sure the base code actually works. So you test it, you debug it, you compile the binary a few times, make sure everything works. When you have nailed it down, then you go into OPSEC modification. So you'll add encryption, garbage code, evasion techniques, so on and so forth. Retest it, debug it, make sure everything else works. And then you finally get into OPSEC check. So you make sure it's good to use, and then you finally have a binary that can work. A lot of this is manual and so on, right? Go on. Oop. Oh, sorry.
This is my cue. So some of you might be wondering what the differences are between OPSEC modification and OPSEC check. So let's start by just talking about OPSEC. So that just means operationally secure. So the difference between the two is that OPSEC modifications are trying to be operationally secure with your payload. So, using good techniques, whereas the OPSEC checks are more like a sanity check on your final deliverable that you're going to be using within the environment, maybe like a client environment.
Cool, thank you. Sorry, I had to add this because he forgot this every time we did a trial run. So this is the only way to make him remember this. But what happens when your actual payload gets burned? As we said, it can happen any time of your project, right? It essentially means now you need to redo all of this work to some extent. So you may need to, you can still potentially use your technique, but you may need to update the code. Now that you have updated the code, you need to make sure it works. Redo your modification. It might be quite simple as like changing the encryption key, updating the garbage code, nothing too complex, but you still need to redo it, recompile your payload, make sure this all works, and so on and so forth. And your payload can get burned for several reasons, right? There could be static analysis, probably the most common one. Then you have dynamic analysis, which is annoying, but it can happen. It could be because you did something wrong as a red teamer, so I don't know, you dumped Mimikatz on the disk or something like that. Or it could be because the blue team did something nice and correct, right? Which is rare, but does happen from time to time as well. Now the last two is probably, okay, it happens with everyone. There's nothing much we can do about it in terms of automation and helping you be better. But the first two, the static analysis and some basic dynamic analysis. Now, there are different levels of dynamic analysis, and if it's, you get burned because of some complex reason, that's fine. But there are some, AV evasion, and if you get burned because your payload wasn't able to bypass an AV sandbox, then it's kind of annoying. So this kind of got us thinking, actually, and all of this results in more manual work and time pressure, right? So especially when it happens during an assessment, or you're in a consulting company and you're a back-to-back project and your payload is burned, it creates an immense amount of time pressure to do all of this again and make sure you have a binary that works. This kind of got us thinking, can we do this better? Can we reliably defeat static analysis? So at least we don't want to get burned by something really stupid. So can we make sure that we consistently defeat static analysis? Probably create more opportunity to defeat dynamic analysis as well. So we're looking at some basic dynamic analysis, not really complex ones. But in essence, can we aid overall payload OPSEC to improve the payload creation efficiency? So can we make this as a part of payload creation cycle to make sure we can do all of these stuff, right? And the answer was yes. We were able to achieve some element of this in GitHub Actions. So what we're actually trying to achieve is we're trying to increase the usability of dynamic analysis evasion technique by consistently defeating static analysis. So what I mean by that is, if I go back for a second, this technique is probably going to get analyzed every time your payload gets burned. So we were trying to make sure is that our payload is not getting burned because of stupid mistake, which essentially means that our dynamic analysis technique lives a little bit longer than it would have otherwise. And we want to try and do it in a little bit more effective way, so a little bit more automated, a little bit more quicker. A quick side too, so what is GitHub Action? I'm sure everyone here knows this already. It's a CI/CD platform that allows you to automate workflows, so you can automate building, testing, and debugging your code as well. It, as the name suggests, it integrates with GitHub, and the aim is really automating routine tasks. It's probably worth mentioning this concept can be applied to any CI/CD platform. GitHub Action is what we use as a team. We're just more comfortable with. We had something similar in my previous place. We used to use Azure Pipeline, so pretty similar concept. So any one of them really work, so on. Let's take a quick side step before we get back into the research. So when we talk about static analysis, dynamic analysis, what are we actually referring to? Okay. Oddly looks different on screen versus what it looks here, but that's fine. So there's a lot of things that happen when you talk about static analysis. These are just 8 of some of the common things that we're looking at. Making sure it's not getting detected because it has similar signature or it has a bad entropy, clear text string and shellcode. Making sure it doesn't have anything suspicious in the binary itself. And of course, it's not limited to these 8 things, but this is kind of the things that we looked at really. Now, dynamic analysis can be of various types as well. We divide into 3 parts, but it could be more than that. So when we say emulation, that's looking at when your binary is actually run in a sandbox environment. Action is what you're trying to perform with that binary itself. So the base technique that you're trying to implement. And then behavior is what you do post implementation of your technique, or what the user is actually doing, or what are you as a red team operator are doing from that C2 connection that you've achieved. And then lastly, we're also trying to defeat logistical challenge. So we're trying to defeat the fact that we have limited time, which means doing this creates a lot of pressure on us. We're trying to make sure there's no, there's less effort, and we want to do it we want to overall increase the shelf life of our payloads as well. So for this talk, we're going to focus on everything that's been marked on green, really. So we're going to look at how we can consistently defeat static analysis, maybe a little bit look at the emulation as well, and all the dynamic, all the logistics challenge as well. And we want to do it effectively. That's the key part of this process. We want to make it effective. We want to make it, easier for we want to make our life easier as red teamers. So when we go back to the research, so as we spoke, this was what our sort of payload dev cycle looked like when we started this research. And somewhere midway, it kind of became this. So we started automating some of the routine tasks. So, making sure adding the modifications, so changing the encryption key or adding garbage code evasion, compiling of the payload, and doing some basic OPSEC checks. So we automated this. Now you can potentially also automate the debug and testing. We didn't do this for our pipeline, I guess. We still haven't implemented this actually, but we can potentially do this, if you had to. And this is what the end looks like for us now. So what we were able to do is add, instead of having one technique for everything, we were able to add more options, which allows you to create more variation in your payload every time your pipeline runs. So instead of having one way to encrypt your shellcode, we're able to implement 3 different things, and each one of them has a bit of variety to itself as well. So your natural language could be anything from Hindi, Urdu, Spanish, English. You can choose it, and you don't have to worry about doing it manually. You probably can define it in your pipeline. It will do it automatically. XOR or your string encryption can be various one. We have implemented 2. You can have different garbage code functions and so on and so forth. You compile it through different variations, and Victor's going to walk through why we have so many different options. But the idea is, instead of having one way of doing it, we have multiple options. It's all automated, so you can create different types of payload, and you don't have to spend manual time to change your code as well. I think it's probably safe to say, and I hope Victor doesn't mind me saying this is not the end of the pipeline. This is where we have got so far. There's definitely a lot more work to be done. We can probably automate debug and testing as well. Probably can have some element of AI if you want to change garbage code. I know there's no talk complete without talking about AI, so we could do that potentially, and so on. Now that's a lot to cover in next hour. So we're going to focus on everything that's marked in yellow. The main reason being, I think we think that's probably the most interesting part of the pipeline. But if there's any other part that you're interested in and you want to know more about, feel free to talk to us afterwards. And yeah, so there you go.
Thank you, Dhruv. Okay, so I'd like to focus more on the pipeline itself and the individual components of the pipeline. So the idea with the pipeline was to create some sort of randomization where possible and swap out components to ultimately have a binary that performs the same sort of actions but looks different on disk once it's been compiled. So let's start by revisiting GitHub Actions in a bit more detail. So here on the screen, you can see a little screenshot of what it could look like. So GitHub Actions are represented in the format of workflow files, which are in YAML. So each workflow file has a set of jobs that are kind of chronological. So they kind of determine the flow of the automation. Each job can have a number of steps which can perform smaller kind of instructions to complete the overall job, and these jobs can be conditional. Furthermore, the workflow files kind of have a trigger, so the trigger will determine when the automation will run. So here it's on line 3, you can see it's set to on push, which means that whenever you push code to the repository, it will run your automated build. Furthermore, like some nice features of GitHub Actions is that you can set a runner environment against every job. So when you have a job like this one, you can specify as to whether it's to run on Ubuntu or perhaps Mac OS or Windows, depending on what kind of what you're doing. You can also import like community jobs. So if anyone released like a public pipeline or some sort of automation, you can kind of pull it into your pipeline and use that. And then another nice few things is that it allows for you to log basically everything that you do within your automation, and it allows you to create artifacts like EXEs or DLLs, etc. So here on the right side, you can see what our pipeline actually looks like. So that's all the files we have. It's really not too many, and they can, you can kind of sum this up as being a combination of YAML, C++, Python, and Bash code. So the YAML, as we mentioned earlier, is to kind of define the overall logic of your pipeline and what the pipeline is going to do. In our case, we opted for C++ code for our malware. That's something I was most comfortable with, and that's therefore what I wanted to use. We used Python, specifically a Python module, to kind of manage the C++ code that we have and kind of manipulate the malware within the pipeline. And then lastly, we use Bash to do any kind of high-level file operations, so renaming files, copying files, maybe running some kind of tool. So obviously, with all this stuff, you also want to, have any kind of relevant resources that you may need for whatever you're trying to achieve. So you might want to have like a shellcode file that you can use within your pipeline, or perhaps you might want to use some sort of precompiled tools like SigThief or ThreadCheck or something like that. And yeah, it's important to note that you can ultimately represent this pipeline in any language that you want or are comfortable using. The only static language here is YAML, which you'll have to use for GitHub Actions. Is that? Nice. So let's talk about templates. So you need some sort of template that you can use within your pipeline in order to to get something useful out of the automation process. So there's a few important things to consider here. You need to have a good base to work from. Your template would ideally contain your like core EDR evasion features, whatever that may be, and it has to kind of allow for you to modify the base template of your malware some way. So we're kind of we're trying to achieve randomization, so we want it to be kind of compatible with this aspect. So just a bit more on good design. So you'll get the most out of this kind of pipeline if your template kind of implements some good MolDev practices, or rather techniques. So these could be things like obfuscation of like strings and shellcode. Things like dynamic function resolving, maybe with get proc address and get module handle, or maybe some assembly, some sort of core EDR evasion, sandbox evasion, and just generally some good OPSEC. So each one of these kind of techniques has multiple implementations. So they're all, within a red team engagement or perhaps across red teaming engagements, you'll be changing these things. So let's say you have a payload with XOR encryption, maybe it gets burnt, and you'll try AES encryption, for example. It's a terrible example, but you might do something like that. You'll swap out a technique. So these are all great kind of candidates for being randomized within the pipeline. So let's look at some things that you should probably avoid. So things like non-obfuscated shellcode, which is statically defined in your template. That's just a bad idea. It's likely to be super signatured and probably unlikely to execute. In fact, yeah, you should just completely avoid using static shellcode. I'll get it soon enough. Yes, so things like direct function calls of like suspicious Windows API functions. So things like open process, virtual alloc, virtual protect, create remote thread, classic example of remote process injection. You want to avoid that, well, at least calling them directly, because they'll show up in your binaries import address table, and it's just a massive red flag. I got it right. And lastly, things like mimicat strings or any kind of string that contains sensitive content or anything that that would be suspicious in any way. Just avoid it.
So I think one thing I want to add is, the point of this talk is not a malware dev 101. So this is not everything you should or shouldn't do, but the conceptual idea is, just because you have a pipeline doesn't mean you don't follow the basic security best practice when you're doing your malware dev. It all depends on how good your base template is, and you're trying to improve it from the pipeline itself.
So yeah, let's look at maybe a template that might be a bit better. So a template that's better or good would have things like obfuscated shellcode and strings. So you could potentially have a decryption key, which is hosted within a domain DNS record. So you can have a CNAME record that contains your decryption key, which you could fetch within your malware. It allows you to kind of control when your malware runs and how far someone can go debugging or reversing your program once it's been burnt. It's also good because you don't have a static key in your malware. So you could also consider something like using indirect syscalls for your EDR evasion logic. So this would be a good candidate for any userland hooking EDR. It obviously may not work so well against ETWTI kind of based EDRs. You'd have some logic to retrieve your hooked syscalls, and you might consider using something like local process injection rather than remote process injection because it's got less IOCs. You might have some sort of sandbox evasion, some random code, etc., or even assembly code. So again, these all kind of provide opportunities for us to randomize these bits. So here we have an example of our template, C++ template here, and you can see it's got some sort of placeholders in the red boxes. And what we can do is we can create a Python function that you might be able to see on the left, which will look for a specific placeholder in our C++ template and then replace it with whatever code we want. So we could create some blocks of C++ code within our Python module, which we can then inject within our C++ template wherever we choose. So you can do this for C++, you can do this for assembly, you can do it for any language that you want to work with, C#, Rust, Go. Yeah, it just fits kind of most things. So this is an example of how you could run this injection logic. So on the left side, you can see an example of us injecting garbage code into our template. You'll see the placeholder garbage_txt. And then on the right side, you can see a snippet of our GitHub Actions workflow file where we call our Python module with some arguments. Okay, let's dive a bit more into the individual OPSEC modifications that we perform in our pipeline. Sorry. So obfuscations. So again, the aim here is to kind of have a variety of obfuscation methods, whether it's encryption or encoding, that we can use randomly, we can select from randomly within our pipeline build to create a somewhat unique binary at the end of the process. So, we've got a number of encryption and encoding techniques for both shellcode and strings, things like XOR, ROT13. We have like a custom assembly function which will do some encoding, and we also use something called lookup tables. So lookup tables, I guess, is something more like encoding, and we thought it was quite interesting, so we'll talk to you about it. So if we consider something like emoji lookup tables, we can basically take our shellcode, and specifically every hexadecimal byte within our shellcode, and map it towards an emoji, which will act as like a legend or a key. And that could look something like this. So we can have here, it looks quite nice, and on the top you can see we have our like our legend, and at the bottom you can see we have our shellcode, which is represented as emojis. So what we can do is we can run a couple loops, and we can derive the original shellcode from these emojis by looking, cross-referencing them. And this is quite good because this results in low entropy if you were to define it within your malware directly, and it looks cool. So again, same as with obfuscation, with garbage code, we're trying to grab some legitimate code and randomly inject it into our binary. So when I say randomly inject, we're trying to end up with different bits of legitimate code across pipeline builds of our malware. So here we just just for the sake of demonstration, we've got 4 mathematical functions, which like quicksort or Fibonacci, and we will just place them within our template and then call them, and it kind of helps create more randomization across your binaries. So in the screenshot, you can see a picture of us defining some C++ code in Python, which will then inject within our template with the methods described before. So let's talk about the kind of modifications we could do relating to evasion. So if we consider sandbox evasion, the aim of it is basically to allow your malware to execute from a sandbox environment or a detonation chamber. So you want to exit out of your program if you identify such an environment. The idea being that you could get to protect your sort of malicious logic from being detected or analyzed. So what you'll do is you'll run some checks and try to break out of the environment as soon as possible. Oops. So we implemented a couple techniques that we can select from within our pipeline. So the first option is something like hardware checks, where we check the CPU cores, RAM, and screen resolution of whatever host is executing our payload. And basically, the more scarce the resources, the more likely it's to be something like a virtual machine or a sandbox of some kind. The other kind of checks we do is we check for mouse movement and for recent files. And that could, from that we can infer whether or not there's a user behind the host executing our malware. Yeah, here we have some examples of our code. Obviously, it could be better. If we had more time, we would customly resolve these functions, would dynamically resolve these functions. Okay. So this is something that we called assembly fluffing. It's probably not called assembly fluffing. It's a random term that we gave it. But so the idea here is we're using indirect syscalls within our template. And here we have an assembly function, which is the indirect syscall. So this indirect syscall function will be used across multiple builds of our malware. So what we want to do is kind of avoid it from being a signature as it's like a core feature of our dynamic analysis evasion. So what we can do is kind of scramble its representation on disk. So on the left, you can see that we've defined some assembly instructions, and these would be no operation instructions. And basically what we're going to try and do is randomly place these assembly instructions within our indirect syscall function in such a way that it just adds extra instructions and changes its representation of the overall function. And yeah, ultimately it won't change the outcome of the indirect syscall function. So on the right, you can see some Python, which will just loop through the original code and then place some of these no-op instructions within that function. And that'll look like this. So everything that's indented is the core indirect syscall function, instructions, and then everything that's been placed at the margin is the no-op instructions that basically doesn't do anything. It just adds some extra fluff. Okay, so let's talk about compilation. So within our pipeline, we implemented several types of compilations, and the idea of that was to kind of end up with different types of binaries or EXEs at the end of the process that we can then compare and analyze and determine which ones would be most suitable moving forward. So each compiler is kind of implemented differently. They all have different ways of optimizing code, and they all place different kinds of functions by default within the IAT of the binary, especially if you're linking to the C runtime. So furthermore, the outputted binaries based on the compiler will have different sizes, different entropies, different strings, etc. So for our pipeline, we've used the cl.exe Visual Studio compiler, LLVM for Windows, MinGW for Windows, and obfuscated LLVM. So you're probably wondering what obfuscated LLVM is, and some of you might already know what it is. So it's basically a custom version of the LLVM compiler. And the LLVM in itself is almost like a back-end module of many compilers today. And what's so good about it is that it allows you, it turns C++ code or C code or any other compatible language into an intermediate representation language, which can then be modified by something known as passes. So the obfuscated LLVM compiler has some predefined passes, which will look to modify the code in such a way that the outcome isn't changed, but it'll perform some sort of obfuscation. So the kind of obfuscation that occurs is it can change the control flow of the program. It could implement some fake loops. It could substitute instructions within the program or perform some sort of string encryption, and ultimately you can expand on it as much as you want, and you can customize this whole process. You have a nice screenshot here showing you how it works. So the pros of this is it has a lot of potential. It's actually been adopted by Cobalt Strike's Mutator kit recently too. The cons is that it's not straightforward to use, build, or customize. Nice. So what we did is we built the obfuscated LLVM compiler within a Docker container, which we then download and use within our pipeline whenever we run the pipeline. So within the screenshot, you can see us using the GitHub Actions workflow file to randomize basically some switches that are passed to the obfuscated LLVM compiler. And then just below that, you can see us passing these environment variables to a Docker container, where we then perform the obfuscated LLVM compiler compilation. So the idea is that we randomize each one of these switches at the number of fake loops, or the number of instructions which are substituted is different across different builds.
Thank you, Victor. So let's look at what the build process actually looks like after we implemented all of these techniques. I forgot. So this is what the pipeline looks like, as we said, right? Now let's, as Victor mentioned initially, that for us the pipeline builds every time we push a new code to the Git repo. So let's assume that we are on a project, we want to build a pipeline, so we did a push, and then we have already implemented the technique and the code template. For the sake of this, let's assume the testing and debugging is already done. As we said, that is something we do manually. So we manually make sure the base technique actually works. But what happens post that is the pipeline goes into OPSEC modification phase, where we'll go through each one of these sections and choose one thing randomly. So we'll go through encryption, take the shellcode that we have, and it will choose a technique randomly, and it will randomize things where possible. So I know Victor spoke about lookup table. So it's going to look different every time in every binary. So even if you have two binary shellcode encrypted using emojis, if Blue Team is trying to decrypt that, it's going to be two different keys for every time. So it's different for every build. Same for strings and encoding as well, or encryption. XOR, it will change the key every build as well. Then it goes garbage code, and it it takes one of the 4 functions we have. Now I think there can be a little bit more work done here, so you can make it more dynamic instead of having 4 set of function, or you can probably get it to pick functions from MSDN websites to make it more legit and things like that. It will go into the evasion phase where we'll choose one of the technique and again randomize where possible, so it could change the sleep time, or if it goes recent file, it can change the parameters and number of recent file we're looking at, and so on. And then for us, it compiles in every one of the compiler now. One very interesting thing about GitHub Action is it's almost like building your payload in a sandbox, because when you actually run the GitHub pipeline, it goes and run in a virtual environment that you physically cannot see. You can see the logs of it, but you cannot see that. So one thing to be really careful on, and I'm not pointing fingers on anyone, but when you try to do this and you're trying to debug if your code is working or not, you may end up rebuilding pipeline every time. But your GitHub tier gives you a free limited amount of time, right? And when you build 24 binaries on every build, it can cost you a lot of money. So just be careful of that, or you can run out of all the time that you have and then you have to pay more. So just to be a little bit careful. But for us, every build will give you 24 different binaries, which is different combination of all the features that we have. Now I'm sure everyone's thinking, how do we know which binary to use? Which is where the OPSEC check will really come in. So now, and Victor will walk us through in detail, but we'll perform OPSEC check on each one of these and see which one is the best suited for the environment that we are on.
Okay, so let's move to OPSEC checks. And so this is like the least sexy part of the pipeline, but it kind of meets all the administrative needs, which Drew will get into later. So one of the checks we do is we use Rastermouse's thread check to basically scan our binaries to make sure there's no, it's not, our binaries aren't signatured before we even use them. So this is a nice sort of sanity check to perform. We also look for kind of keywords within our binaries. So, what you could do if you're a consultancy is you could look for client names within your binaries to make sure that they're not being leaked to other clients, or you could look for, any other sensitive keywords or strings that you may have. You could scan your binaries with YaraForge, which is basically a Yara rule set, which is publicly maintained. You can look for bad bytes, similar to thread check. You can look at your binaries entropy levels to kind of determine whether or not it'd be suspicious and whether you should use them. You can look at the imports and exports of your binary, and if you wanted to, you could grab the binary file hashes and kind of look them up and see if they were malicious before using.
Yeah, I know Victor said this is the least sexy part of the pipeline. I do agree to that, but if we have any red team managers, senior people who have juniors working with them, I think this is probably the most important part of the pipeline, because it allows you to make sure that you have that consistency every time a payload has been built. So you make sure that if someone less experienced, or even us as seniors, when we try to do this under time pressure, can make that error, is just having that peace of mind that everything that we use is being checked once before it goes to the client. It gives you a little bit of reassurance that it's not going to get detected because something of stupid.
So here's just an example of how we use thread check within our pipeline. So we basically compile all our binaries and then run thread check against it. But yeah, this slide is mostly just credit to Rastermouse. So when you perform your builds, it's nice to have some sort of report as to what happened and what occurred within the build process. So on the right here, on the left, you can see a big list of all the things that were compiled, and you can see, whether they passed or failed the different OPSEC checks. So you can see here most of them passed the thread check and YaraForge checks. You can see things like the file hashes there and the entropy levels. You can also kind of see on the top right here the kind of method, the random components that were selected. So as in the type of shellcode encryption, you see here it's random lang. It's basically all the shellcode was encrypted in some sort of random language. It could be Hindi, Chinese, whatever. And then we know what kind of signature was used to perform the fake signaturing, fake signing of the binary, and what kind of encryption was used for encrypting strings, and then lastly, what sandbox evasion technique was chosen for this particular build. So we've talked to you about our amazing pipeline and all the hard work we put in and how cool it is, but you're probably interested in the actual results. So here we've basically run our pipeline 3 times. So these are, and then from each pipeline build, we've selected 1 binary. So the idea is that every pipeline build would have selected a different set of techniques that would have been randomized. And yeah, so you have 3 different binaries. So the first one was compiled with LLVM for Windows, the second one with MinGW for Windows, and the last one with our obfuscate LLVM compiler. The second and third both used XOR for the shellcode encoding, whereas the first was Urdu lookup tables. They all had the same sort of string encryption method, and again, the first and third had the same sandbox evasion technique, which was hardware checks, and then the second one had a mouse and recent files check. Lastly, the second binary was also fake signed with the MSI Afterburner setup tool, and the last binary, sample 3, was also padded with some random junk to make it a lot larger and hopefully harder to analyze. So we'll just run through some kind of characteristics of these binaries. We put them all in PE Studio to kind of see what the import tables look like, and a number of functions were kind of identified as being malicious. However, the one that kind of really stands out is in the second binary, and that has a virtual protect function. There's a table from that Mezzo released on Twitter just a week ago, and I stole his screenshot, his image, and basically used it here. But you can see that the percentage of occurrences of these malicious functions, and virtual protect is in that list. We also wanted to show you the kind of control flow graphs of each binary. So you can see here the first and second binary are very similar in the kind of conditions and jumps and loops within the binaries. So the flow is all very similar. Whereas the obfuscated LLVM compiler, which we were talking about earlier, that really completely scrambled and mangled the binary. So the flow is completely different. There's a lot more checks and loops and all sorts of things in there. So it's a lot harder to kind of reverse and understand.
One thing I would actually like to add is one thing that I find really interesting here is that, and Victor, correct me if I'm wrong, but the virtual protect function in the sample2 is not actually in our base code itself. So it's something that was actually added by the compiler, which I would have actually never really paid attention to unless I was actually comparing a few different options. So I think that was a really cool thing that we found out. All right, let's look at the first, the fact that the functions and the flow. How many of you think that sample 3 is actually the best binary to use in an engagement? Can I get a raise of hand if anyone thinks sample 3 is the best one? No? Sample 2? Sample 1? All right, cool. Let's see.
So the answer was actually sample 2, which is odd because it had the virtual protect function within its import table.
Sorry, can I add? Andy, why did you think it was sample 2 and not sample 3?
It's simplest.
Sorry?
The more complicated you make a binary, the more likely it's going to get picked. Sorry, I just stole your thunder.
No, that's all right. And obviously we see that the obfuscated LLVM one has the most detections out of the 3. But overall, I think all of them are quite low. So what can we kind of infer from this? Well, more complex isn't necessarily better. So it might be about finding, you might have to kind of find the sweet spot between doing too much and doing too little. And it could also, it might be vendor specific as to what binary you should choose and things like that.
All right, so let's look at the final outcomes that we have. So at the start of the presentation, we had 4 questions that we asked to ourselves when we started doing this research. Can we do this better? So can we reliably defeat static analysis? I think we were quite happy with the answer. I think we can do that definitely with continuous R&D and the pipeline, making sure there's checks in place so we don't do anything stupid. which essentially does create some opportunity to defeat and focus dynamic analysis. So, of course, the focus is not to always defeat it, but it can help you a little bit better. And the next does it overall aids the payload OPSEC? The answer is definitely yes, because you're doing a bunch of checks. You're adding randomization. Every binary is different. I think it's quite fun to throw blue team away when you have a bit of Chinese characters in your payload or Russian language in your payload. So that could be quite fun as well. And then overall, does it improve the efficiency? Definitely. Something that used to take us a day or two to update the code, change stuff. Now just takes us a couple minutes to do it. It does cost me a lot more money when I let this guy develop stuff, but it does help for sure. Yeah, and in conclusion, the idea really here is the scalability and banking on capability. So the more randomization you can add, the better it can become. And then and I think the main thing is also it can be tailored. So of course we do it for our C2 and stuff, but you can implement the same concept for any kind of payloads that you want to develop really.
So given more time, what would we kind of do as improvements? So we might consider randomly choosing EDR evasion techniques that we can inject within our template. So you could be banking up these evasion techniques in-house and then randomly select one within your template. Would probably consider improving the obfuscated LLVM compiler and creating our own kind of obfuscation passes rather than using something public from the internet. Would probably try and figure out more about the dynamic analysis, well, rather the actions that relate to our binaries by, implementing some sort of restricted EDR or other form of dynamic analysis within our pipeline. And lastly, we'd look at handling different types of output files like DLLs or macros or whatever.
I think that's pretty much it. Thank you, everyone. All right, we got a couple minutes if anyone has any question. Yeah, go for it.
Just regarding the antivirus results, I'm just curious what engines actually detected the
Well, funnily, I think the one that was constant across all three, was some Chinese AV called BP or something. I can't remember. But the none of the really big ones were consistently defeating all three. It was a different kind of reputable AV that was detecting each one of the three.
No, so the only way to do it actually run it on GitHub. I think you can have GitHub offline runners, but that still costs you, which is what I was saying. It does cost us a bunch of money, and trying to explain that the business can be tricky, but it just pays off definitely. Anyone else? No? I think that's so. Yeah. Oh, you.
I was just curious about how you had the trees that showed how the binaries were created. Is that something that you wrote custom, or is that just a piece of software that does that already?
Oh no, quite a few of the decompilers will have a graph view. So this one was IDA free, but I think x64 DBG would have it too. A new template?
Component.
Oh, well, if you use ChatGPT, you could probably do it really fast. Yeah, I think normally you want to test it, make sure it's robust. So I tested all the individual blocks of code that we injected into the template. You want to make sure it actually works properly and there's no bugs in it. And then once you're really happy with it, then you'd add it to your sort of database of code.
Are you guys only doing Windows payloads? Because this is very Windows-centric. Are you doing it for Linux and Mac OS as well?
I think the intention is there to do with macOS as well. But of course, I think it was easiest to start with Windows and kind of develop from there. So at the moment, it's only Windows, yeah. Anyone else? No? All right, cool. Thank you, everyone.
Thank you.
I think we're. I think that's time. We'll get kicked off. All right then, Sheffield. How are we doing? Scott, quite. Thank you. There we go. There is a lot of audience participation in this talk, so I'm going to do that again, and I want everyone to do what he did. Hello there, Sheffield. There we go. Right, we're started as we mean to go on. This is Tales of Dominica. It's about finding kind of type 0 or DOM-based cross-site scripting, specifically where other people may not. And I did Google what the age rating of 15 meant, because I just kind of popped that on my submission, and it means that I'm not allowed to swear, but not to swear aggressively. So if anyone asks any stupid fucking questions at the end, we might have to upgrade this to 18. Everyone having a nice day so far, at least, though? Minus the horrific temperature that it's been. I am melting underneath this wig, but it's the only time I get an opportunity to have hair, as I am a bald man, so we do what we must. We do what we must. So, by way of introduction, I'm Liam. I'm an application security tester, a dual check team leader, and one of the testers over at KPMG. Here's all my kind of social stuff. I've got a Twitter that's just me rambling. The GitHub does have one or two cool tools on. Obviously, I have to say that, though, because it's mine. You can connect with me on LinkedIn. I don't have one of those crazy QR codes because one, I don't trust myself to generate them, and two, I'm not that tech savvy. Or you can email me, at liam@grayrose.com. Please attach cat pictures to your emails. I might actually respond to some questions there. Otherwise, it's probably not getting answered. I'm very bad at staying on top of that. Right then. So, here's some background. There's generally considered three types of cross-site scripting. There's reflected, or non-persistent, stored or persistent, and then there's DOM-based, which can either be stored or reflected, but we still call it a different type because it's a slightly different injection technique. Now, reflected or stored or non-persistent is pretty self-explanatory. Server doesn't store the payload, and the execution happens when the browser renders the content. We're all on the same page. Same with stored, but content is in fact stored on the server and then returned multiple times. So if you request the same page, it will return the same payload even without you submitting it. Right. And then execution happens when the browser renders the content. And then there's DOM-based. Content is injected back into the DOM. We'll get on to what the DOM is in a second if you're not up to speed on that. And then execution happens after this injection occurs, which means that it's a little bit harder to detect. Some people have started missing it, and so it's a good one. If you are, actually, that's a good question. Are there any pen testers in the room? Well, ooh, many pen testers. Lovely. Any students looking at getting into pen testing? That was the right answer. Well, you're going to be an application specialist after this talk, so I don't want any nonsense about red teaming on your applications when I see them come in. Right then. So some background, because we all need to start somewhere. I first got interested in client-side JavaScript facilitated vulnerabilities when I saw a talk by a guy called Tom Nom Nom, or that's his Twitter handle, at DC151 in Leeds, and I was immediately fascinated. The idea that you could attack a user and not have the attack be as a result of a server-side interaction, it was in fact how somebody's built the front end of a site, was quite interesting to me, and so I immediately got obsessed. Quick aside, who here knows what DOM is? Well, lovely. Right, if I get this horribly wrong, can you jump in and correct me? Basically, it's a programming interface for JavaScript to interact with the HTML of a page. And in this context, it's what's generated after the HTML of a page is passed, at which point the JavaScript can start running around and doing its stuff. And this is what we're going to be focusing on today. Now, who here has to work with JavaScript? You poor bastard. It's a bit horrific, as we're going to demonstrate now. You may have seen something to this effect, but JavaScript really funky. So we have 2 + 2, that's 4. We're all on the same page. You know, we all successfully got through year 2 maths. Excellent. 2 + 2, string concatenation. We get 22. Lovely. 2 + 2 - 2. Right. What are we doing here? What are we thinking? Any guesses? Come on. You look like you know. Not a sausage, okay. 20, bollocks. Immediately, there is a wrench in the works. Now, the reasoning behind all this is something called a type inference, which JavaScript does a lot of, but the point of it is that it's actually really strange. It's very weird. It does things that it shouldn't do, and it behaves in a way that's not very explicit. So, I needed some help. You may have noticed I have some props here to help me today. Red wine it's not great lighting, but that is a glass of red wine. I have 3 more up here, so if anybody does want a glass of red wine, come up and grab one. Because little did I know, or I found this out the hard way, JavaScript's really confusing. It's quite complicated, and it was difficult for me to get my head around. I was a Python guy originally, and then moved to Ruby, and then JavaScript just didn't follow any of the nice structure that I was used to. So naturally, I had some red wine, and I immediately became an expert to test this theory. Who said that? We can be friends. So in reality, I used a mixture of Code Wars, which is a site that I can signpost you to, and we did a lot of kind of single-page JavaScript testing. So if you do want to kind of get up to speed on JavaScript, or at least get a little bit better of it, there are some great resources out there for you to learn it and learn all its intricacies, specifically when it comes to kind of attacking and exploiting it. There's also some great books like Violent JavaScript, and the excellent research done by Portswigger, Gareth Hayes, that kind of ilk, to kind of further research into that. But I would also recommend having some red wine. Always drink responsibly, please. Right, are we ready? Yeah, come on. Are you ready? Yeah. Woohoo! Right, we've learned that JavaScript's dodgy. There's 3 types of XSS, and that red wine is really tasty. If we're all sitting comfortably, let's get to the fun bit, which is exploiting DOM-based XSS. So, first step of exploiting DOM XSS is identifying something called the source and something called the sink. Sources are the place where user-supplied content is passed into JavaScript, and then the sink is when that content is incorporated back into the DOM, or otherwise processed in an unsafe manner, which we'll get to in a little bit. Let's have a look at a very obvious example of this. Don't worry, this isn't a code with me. I don't want anybody falling asleep in the audience. So, we have a form, its method is get, actions challenge 1, right? Posts to some challenges. There are some labs for this, so you do have homework, unfortunately. We've got a script. All that does is it defines a function called tracking, which sets the inner HTML of an element that with the ID tracking, so this element here, to search. And then we define some URL params from our URL search parameters, which we pass in window allocation to search. That's just URL parameters. I'm sure we've all seen some of those before. Search term, we just get the search, so search equals, and then we call that function. That then injects that into there. Everybody with me so far? Lovely. I got some nods. So surely the old reliable will work. Now, who here's messed around with cross-site scripting before? Obviously there's some pen testers in here, so I should see plenty of hands. Lovely. How many of you use Script Alert 1 script as like the basic payload that you just spray everywhere? Right, lovely. Excellent. Look at that, 2 hands up. This man is a script lover in the back. Now, surely that'll work here, right? What do we think? No. So you can see it's injected, and you see it's in there, but we're not getting any execution, which is strange. Surely we should do, because that is valid HTML, and it's in script tags, and we're clearly calling our alert. Let's look at the W3 docs for HTML5, said nobody ever. But here we are. Here's an interesting note. Script elements inserted using inner HTML do not execute when they are inserted. Right, so we've got to think of another way of getting our execution that's not using script tags. So, wait, can we do that? Here, you can see that I've injected an image tag. So if we inject an image tag, this one I've given a valid source of a lovely set of roses. There's a theme to this, if you couldn't tell. And look, we get our rendering. Now, is there anything we can do with image tags? Thank you. If we supply an invalid source and then add the on error to it, we might just be cooking with gas. We might just get something. And we do. So what happens there is we supply our image with an invalid error. The on-error event handler then calls, because X, so /X on a site is not a valid, it's not a valid path, it's not a valid image. On-error fires, and we get our alert. So I always wanted to build a set of labs where /X and /1 actually resolve to valid images, just to see people banging their heads against a wall. I got called evil when I tried to do that at one of my previous companies, and yeah, got told off. So you're safe for now. Right, bang. Now, we're going to start seeing why this is such a difficult vulnerability, or perhaps not such a difficult one, but why it's missed by so many testers, or at least by enough testers that I'm sat here banging on about it today. If we can see our request and our response here, we can see that we've got get challenge 1, search, image, source equals X, on error equals alert 1. Right. Now, if you were scanning for this, if you had an intruder attack and you were fuzzing that parameter, right, what you'd do is you'd grab a whole big list of payloads, and you'd see if they were reflected, right? You can tick that selection in the intruder. You can say, is this reflected? And it goes yes, and it flags it up to you, and you're like, awesome, I've got reflected cross-site scripting. It goes into your port, you call your client, you gloat a little bit, maybe not do the last step there. But as you can see here, it's not reflected. It's not in the response. So if you were doing your intruder attack, you'd find diddly squat, and you might miss something. Now, I have actually, on a more genuine note, seen this missed quite regularly by certain pen testers, or over the last probably year and a half, there's been at least 10 to 15 incidents of where we've come in, we've found DOM-based cross-site scripting when a previous pen test has found no XSS vulnerabilities. I won't be naming and shaming pen testing firms here, but you know who you are. Now let's get on to something slightly more advanced. There are some pen testers in the room, and I don't want to bore you to death with the very basics, but we've gone through them anyway. Right, beating basic protections. So we've got our basic payload, basic idea, but again, we just need to go back to what the methodology is, which is identify source, identify sink, find a way from getting from source to sink with some execution, and Bob's your uncle. So I'm really enjoying that. I have a laser pointer. I need to buy one of these. We have a slightly more, anyway, back to the talk. If we have a slightly more complicated set of functions here, right? Well, we've still got function tracking. We're still grabbing the search parameter. We're still being passed to tracking, but this is now even dodgier. We can see that we're evaling a string here. We've got document.getElementById by ID tracker.html equals, and then we define our image. Source is the search term, and that. So this was like a pretty janky way of doing like search term tracking. I haven't seen this in the wild in a little while, but at one point it was occasionally used, and this is just a basic example anyway. So here we are. Now, how do we think we're going to force kind of execution here? Any ideas? Yes, mate, you in the back. Now, that an interesting one. You can single quote. I've got two answers. Right, which one are we going to go with? Well, there's a couple of things we can do. You can do something called attribute injection, which is what you were getting at there, where we try and form this into an invalid tag. But your man up there with a single quote has a better idea, I think. Go to the next one. I got an encode URI in there. I do, right, okay. So the reason why we're beating basic protections is because of the encode URI call, which is going to encode what's going on in here. Forgive me, I've had some red wine. So what we can see is when we go for your attribute injection attack up there, you can see that the space is encoded, which means that then never gets interpreted properly, and you don't break out, and then you don't set your on error. Double quotes are also encoded as well, so you wouldn't be able to kind of break out of that and get to code execution that way. So maybe the eval was the sink, not the image tag. So we go back to the drawing board, and we have a look at this. And encode URI doesn't encode single quotes, so 10 points for the man back there. You get a second red wine if you want it. Start using these as prizes. Oh no, the base has come off. Beautiful. So we can break out the inner HTML call and call alert1 instead. Obviously, you'd make it a bit nastier if you're actually going to do this. But effectively, where's my pointer? We have %27, which is a single quote. Yes, thank you. Then we end the comment. We call alert1, and then we just comment out the rest of the string. And then we have our alert1. And we can see why it does that here. Now, when I'm actually building these payloads, and sometimes they're a little bit more complicated than that, I will go through and either write this out on pen and paper or do it in a text document, because it just makes it a little bit easier to build up. VS Code can add some excellent kind of autocompletes to it as well. Makes it a little bit easier. But as you can see here, eval has our search term. Our search term is this, so when that then gets incorporated all into one, we can see that we document in HTML image source equals, and then we just close that there. We're starting a new statement, alert1, and the rest of that is then commented out. And when that gets evaled, this fires first, this fires second, and then that's fine, that works, and then we get to our alert1, and we get our cross-site scripting issue. And we've beaten some basic protections. And again, everyone thinks you're amazing, your client loves you, or they shout at you. Right, here's an interesting one. I have some, I don't know, interesting hobbies. That's me at the bottom, looking very cross and trying to attack this man's ankle, and that's him at the top. He's lovely, but he was looking a bit worried there, because if I complete that, for those who don't know, his knee explodes, which is very bad. So none of us wanted that. The point of this is that this is missed quite often by other pen testing firms. And if you can do it, it makes you look really good. It makes you look really good to your client, and it makes you look really good to your bosses who are going, look at this person. They can find all these really crazy vulnerabilities. Little did you know, all you did was you listened to my SteelCon talk. Boom. You can thank me for all the promotions later. But no, seriously, your ability to find interesting vulnerabilities is part of what you're marked on. It's not everything, and it obviously varies business to business. But if you can build up a strong baseline and then start to branch out into some slightly more niche vulnerabilities, but still ones that you're regularly going to see on app tests, it can really help you. Can we fix it? We can, fortunately. It's pretty easy. Well, I say that. Depending on kind of what you're pushing to, it's just character encoding. It's your standard kind of user encoding, making sure that you don't trust user-supplied content, and making sure that user-supplied content isn't just not trusted by your backend, but it's also not trusted by the front end of your application as well. So if there is JavaScript that is picking things up and doing kind of all the crazy fun stuff that makes apps look really, really cool nowadays, make sure that it's not trusting user-supplied content either. It's using things like libraries like DOM Purify and so on and so forth that have the ability to properly escape these strings. DOM Purify does have some vulnerabilities in it, so maybe don't push that one to production. But there are other vulnerabilities out there. There are other examples of good what am I thinking? Good JavaScript protection libraries out there. Now, live demos have always gone perfectly for me, so let's see if we can. Does that go into the right screen? We're on the other side. You can find these labs on GitHub. You download them. It's a simple Python thing. There may be, I'll looking at getting these hosted somewhere later, maybe from the man in the back there. We'll talking about that in a second. But these are some JavaScript labs. The easy ones, again, they're not going to be found in the real world, not really, unless you're testing very old applications. But the idea is you start to learn to go from source to sink. Medium. Again, these start to be a little bit more realistic. Hard, I've made some of the hard ones just a bit nuts because I'm a bit of a sadist. But the real life ones, these are taken from real engagements. In fact, You've Been Framed, there are a couple more that are going to be pushed to that. Just taking you to get round to actually writing them. You've Been Framed was taken from an engagement we were on where 10 years of pen tests, of annual pen tests, had missed the vulnerability. It was a pain. It took me about 7 hours to find across the course of the engagement, but we did manage to get it popped. and it was a really interesting one. If you can solve that one, drop me a message on LinkedIn because we're hiring. We'll see. We'll put this this theory into practice then. Any volunteers? Let's pick one. We'll solve it. I'm going to start picking on people. Right, you mate, with the nice hair. Go on. Which one are we doing? Don't pick the hard one. Or do. Click. Ooh. Okay, we'll do that. It's medium DOM exercise. Some lazy developer left an auto clicker in here. Oops. I can call them lazy because it was me. So let's see what goes on here. We inspect some element. What's going on? Oh, right, yeah, I can do. It's going to be a bit easier. Give me 1 second. Is that a bit better? Can you see that? Lovely. Can anyone see that, or do we need that a bit bigger as well? Always pray to the demo gods before you do a demo. So this is the function that we're attacking this time. We've got document get element by ID tracker, href equals search, and then we're getting the document element by ID, the hash, and we're going to click on it. We've got our URL search parameters. Again, simple. We're decoding the URI, decode URI, so opposite of encode URI on URL params.getSearch, and then hashed equals the window.location.hash.slice1, so that grabs everything after the, well, actually, go on then. Any more for any more? Grabs everything after the hash, yeah, lovely. Set you up for that one. And then if the search term is not null, we run tracking on the search term to hash, so effectively what it does is it grabs the ID of hash, it clicks on it after setting the href of a tracker. So what we can do here is we can nice and easily go back and we can set, let's search for something. What are we going to search for? Lovely, thank you. So there you go. Cannot read properties of null. So let's instead grab in here. We've got an ID tracker. We can see the href there is of cats. Apologies, I appreciate that's a bit small. Can we do anything cool with hrefs? Top man, right. You looking for a job? No, I'm joking. And we get our execution. It's the auto clicker in there. Again, not the most realistic in the world. People trend not to leave auto clickers running around in their applications, but it helps to kind of prove the point, and a bit of lateral thinking there. Right then, we have whizzed through this, so let's see if I can find my slides. As I said before, here's some resources. The Portswigger have some excellent research into DOM-based cross-site scripting. They also have, what's it called? DOM Invader, I think, is what they've called it. DOM Invader will find some of those. It'll find most of the basic ones and some of the medium ones. When you start to get slightly more advanced, it picks up on a little bit, but not so much. But it is still a really great tool. And obviously, Portswigger are effectively leading in the applications research side of things. That's a link to the GitHub where all the code is. There's Code Wars if you want to learn about JavaScript, if you're a masochist. And xsse.uk is a site developed by the gentleman there. It's more cross-site scripting labs, and over the course of the next kind of couple of weeks, hopefully we'll be porting a lot of the Dominic labs into there, so you can complete them and earn loads of prizes, or points at least. Prizes optional. Do we have any questions? Loads, lovely. Yes, mate.
You said encode URI doesn't encode single quotes, right? Do you know why that is?
I don't. I limit myself to only reading one HTML spec doc per talk. I don't, unfortunately, but it doesn't. It's a kind of one of the pieces of interesting behaviour that you need to bear in mind. Yes, mate. Excellent.
When you're finding that success, what's the best way you can chain it with stuff that else to get something from?
Ooh. We got. I mean, it was stored, and all the cookie flags were there. It was using JWTs, but for some reason we were unable to grab them. There was a length limit on the field, but we could pull in an external source, which there was functionality in the application that allowed administrators to set the user permissions of another user. So we got ourselves in as a low-level user. It was a single-page app. If you've ever worked with single-page apps or ever tested them, normally you can get a list of URLs from the kind of JS source file or app.js file. We'd found a weird one that looked like it was a user permissions editor. So we'd gone in, or like a content editor, we'd kind of there was this kind of broken access control, so you could inject your payload into the single page app as a low permissioned user. You're meant to be like medium or high, and then the payload fired and it set our account up to an admin. And then that was the coolest exercise I found. But most of the time you're rushed off your feet and you get like alert document.domain and then call it a day. Yeah. Yes, mate.
Sometimes see XSS in like JavaScript libraries like jQuery, UI,
Mhm.
and found pretty rare that that's actually exploitable. I just wondered, is there any of those that you found you've had like good mileage with?
No, not. The JavaScript ones, or the JavaScript library ones, are quite difficult to exploit, because normally it's like one very weird use of a kind of a slightly obscure function that they have in there that is the vulnerable bit. So I haven't found any in the wild, no. But some of the labs may touch on that. Yes.
It takes URL encoded stuff and then it writes it to DOM. It undoes it. But it's only if you have a specific object like the jQuery.
Cheers. Could you send me that as well? Lovely, thank you. Yes, mate.
When you say sites implementing strong CSP, basically, we worry about this
no, no. It's CSPs are good. You should set them. But there's a whole kind of world of bypassing CSPs and kind of circumnavigating them. If it's really, really restrictive, you can force cross-site scripting to be less of an issue, or at least make the barrier for entry for it quite a lot higher. But it's not a kind of one-stop shop. No.
My site is 4 different branches, 4 different CSP.
But with unsafe value, nonsense.
Again, it reduces the risk. Yeah, it reduces the risk. It is still possible to bypass those in certain circumstances. That's what the AWS WAF, which only scans the first like 8 kilobytes, and you can get past it instantly. Yeah, that's a good fun one. Any more for any more? Yes, mate.
You're talking about how it took you 7 hours to find that.
Mm-hmm.
I was just curious, how did you already have an inkling that it was there?
I had a little. There was a. Oh, because I had one. One, the no, one, the client said there's absolutely no way you're breaking that, and that is a red rag to a bull. You ever want unpaid overtime from your pen testers, say that to them. They'll go to the end of the earth to break it. And the second one is I just had the script. Just there was something at the back of my mind that went, that's vulnerable. That's going to be broken, and I went off on a bit of a mad one and proved it. But yeah, is that everyone happy? Excellent. Well, thank you very much, and see you at the after party, and most importantly, happy hacking.
It would help if I switched it on. Right, good afternoon. This session, in case you still want to escape, is about AppSec for developers. And I've called it the good, the bad, and the ugly, which basically means you don't know what to expect. So, as it is customary, I shall talk about me. Now, I'm old, I'm grumpy, I also look like a Dog's Trust knitted puppet, which my wife was very excited one day when that came on the television as an advert, and she shouted, "Jerry, Jerry, you're on television." I have since maybe had a bit more stubble, and this doesn't help the thing. Now, I said I'm old, I do mean it. I remember Java 1.0. For those of you children that don't remember Java 1.0, this was something in 28 years ago. Must be older. Anyway, and I remember how exciting it was when Java 1.1 came out, and there were anonymous lambdas, when lambdas meant something completely different. Actually, we're called anonymous classes. We now call them lambdas, and they've got nothing to do with serverless. Now, if you're about to start panicking that this is going to be a really technical talk, don't worry. This is about as technical as it will get. So, I've worked with a lot of people. I've done a bit of AppSec, and at the moment I'm mainly getting frustrated and bashing my head against walls. Now, this is a photo of my son. I thought, why not put that in? It's in the afternoon. He likes jigsaws. Everyone outside is doing jigsaws. It fits all in. I come from over the mountain in the right place of the War of Roses, but actually I'm Austrian, so it doesn't really count. At one point, we've all been at war with each other, haven't we? Now, I wanted to use this picture simply because there's always multiple ways to get to the same place. Of course, sometimes Snake Pass is closed and snowed under, and then it doesn't work. Yeah, this is an AppSec presentation. Don't worry. It is the good, the bad, and the ugly. And I think there is a contractual obligation at today's date that you have to somewhere make a joke about CrowdStrike. So, yes. I mean, as you will see, I've also got a MacBook, so, you know, I am putting myself in the... I don't know, I wanted to get the joke in, and it felt the right place. Now, what this talk is really about is best explained by an XKCD comic as to how you write good code. Now, this is a flowchart. It describes the process. And as you will see, it is pretty broken. Normally, you don't get to good code until you sort of, you don't really know. Typically, there are 3 approaches. Now, in my LinkedIn profile, I call myself a agile fundamentalist. I will explain what that means. It doesn't sound as bad as it is. And I am not about to force agile methodology courses down your throat. Don't worry. I am a consultant. I will not hurt you. But I do think that in terms of software development, doing it in an agile way, which can best be described as doing software development in small steps, is the way. The other way of doing it is waterfall, which basically means that you approach software development just like building a house. Somebody says, I want a house, there's the requirements phase, then you give it to an architect who writes up all the designs, then you give it to the builder who will build it for you, then you give it to the buildings inspector who will inspect it, and then you'll move in. Software development isn't quite like that, isn't it? I mean, we tend to think it's like building a rocket in order to go to the moon, but actually the nice thing about software is that you can easily build it replace it, build it again, replace it, build it again. Unlike building a house, it doesn't take quite a lot of builders with a lot of bricks to tear something down and build it again. It's very cheap to do something again. So you can actually do things where you can make little improvements, show it to the user, get the feedback, make more improvements. You can't do that with a house, really. You know, oh, I've put a door here, an entry door here in your toilet. Is that right? No, let's change that. Typically, that happens in plans. The problem with plans, and this is why I don't like waterfall, is that usually plans don't. What's the saying? Survive contact with the enemy. Calling user an enemy is maybe a bit strong, but we all know that the problem exists between keyboard and chair more than often. Right, I'm getting distracted. There is a third way of building software, which is kind of like letting Dave, the cowboy builder, build you your garage, and then you find that it's completely broken. You just go in and have got no methodology. You throw code at it. An ex-colleague of mine used to call it programming by chicken sacrifice, where you just put code in it, throw it at a compiler, and if it works, then that's fine. Now, let's get serious here. About a year ago, there was an article by the consultancy McKinsey about measuring software development productivity. It was widely condemned as being bollocks. Now this is Dave Farley, who makes lots of videos about creating software in an agile way, explaining as to why this wouldn't necessarily work. One of my favorite sort of rubbishing of the article was done by Dan North, which, if you look it up, is really quite cool. The thing that really triggered me was this bit in the article, which basically McKinsey states that software development is two loops. There's sort of this inner loop where people build and code and create the things in a very quickly, and they're saying that this is the thing that you want to. Don't take pictures of it. This is really rubbish. This is the thing that you really want to accelerate, and this outer loop of deploying at scale and integrating and having lots of meetings and, God forbid, security is something that you want to minimize. So it's kind of like putting to the right, and I really don't agree with that, because who here is working in the software industry? Who here has got a security function that works like this? I give you time to read it. This is a rant that I had on my blog, as how I felt years and years ago about security, where you have them in an ivory tower that come down at the end, and the head of security screams at you just before you want to release something. Why did nobody tell me about this? This isn't safe. This can't go through. This wouldn't pass any of our gates. Who's working in a place like that? Yes, a few. Where are you working that didn't put their hand up? It's a good place to work. Now, this is actually something that happened to me quite a lot, where projects get done, and then right at the end somebody thinks, oh, maybe we need to have somebody from security to take a look at it. And then what does it do? It gets really, really expensive to fix it, because there is no time to go and say, oh, we need to go back and fix something, and oh, this database isn't actually encrypted, and authentication, yes, we've heard of it. Again, based on real occurrences. But then you don't have the time to fix it, because the product manager will want to release it. All the marketing material has been lined up, and you can't really do anything anymore. So a risk meeting is usually called, and the product owner says, we accept the risk. And then it gets stuffed in the technical debt backlog and never fixed again. This is sort of a comic which I quite like in terms of the development methodologies. That's where security often gets called in after it happened. This is really sort of the bad way of doing security in my book. Now, the problem is this. Typically, you've got developers blaming security for giving them ridiculous things, hoops to jump through, and security going, these developers, they really don't understand anything that they're doing. How can they not know not to use MD5 as a hashing algorithm? How can they not know that you can't just put all this personal data unencrypted over the wire? How? But the problem is, it's usually when the finger pointing starts, it's too late. Now that's why I want to talk to you about the Agile Manifesto. This is why I call myself a fundamentalist. This happened in a meeting in Snowbird, a ski resort in America, where some people that I quite respect got together and said, we want to put together some principles of how to develop software. And since then, Agile has become to mean doing stand-ups and using Jira. Who's doing stand-ups and who's using Jira? Yes. It's got nothing to do with Agile. It's what people think that Agile is, but actually Agile is these things. 4 very simple principles. You want to do individuals and interactions over processes and tools. You want working software over comprehensive documentation. You want customer collaboration over contract negotiation, and you want to respond to change over following a plan. Now, the really important thing is this bit here. This is not an exclusive either-or situation. Too often, I'm having conversations with my head of security saying, oh, you Agile people, you're just cowboys. You just want to do everything without testing anything and not planning anything. That's not what Agile means. Agile isn't about moving fast and breaking things. It is being very methodical, get the word out, and it is working in small steps